So, good morning to all the students, all the participants. A very warm welcome to all the speakers today. On behalf of Dayanand Sagar University, I would like to welcome all the speakers. I will introduce each of the speakers, but a very warm welcome to all the students as well as the entire admission team who have been the pillar behind getting all the students on this particular Friday morning. I'm sure all of you, all the students will definitely enjoy this session. It's going to be an interactive session. I'm sure all the students today are worried because of the pandemic. The examinations are not, clear when they are going to happen. On the other side, we are worried when the university admission process will happen, when the results will come, when will I get a seat in a good university. Between all of this, we also need to understand that we need to know what kind of career choices do we have. And then and Sagar University has come forward today to give the details about the way forward in terms of careers in engineering. So, a warm welcome to all of you. I take the opportunity of introducing the speakers for today. I'll also give my introduction. My name is Srinivas Shinde. I'm the Chief Marketing Officer at Dayanand Sagar University and supported by a full dynamic, motivated team of admission team who have actually put up this show. I would like to welcome Honorable Vice Chancellor from Dayanand Sagar University, Dr. K.N.B. Murthy sir. Due to some emergencies today, the Dean sir, due to some medical emergencies today, the Dean sir would not be available. However, the responsibility of giving the complete details about the School of Engineering will be with Dr. Sanjay Chitnis. He is the Professor and Director, Innovation and Entrepreneurship and Chairman for the CEC department at DSU. We also like to welcome an industry veteran from IIT Madras with 35 years of experience with TCS, Mr. Arvind Srinivas. Arvind Srinivas sir is going to give the perspective in terms of how the industry looks forward to when it comes to a curriculum from premium universities. What would be the response? What is the expectation from the students? A complete industry exposure in terms of your career choices will be shared by Shri Arvind Srinivas. I also like to welcome Dr. Vaibhav Meshram, Professor and Chairman from ECE Department. Warm welcome to you, sir. I also like to welcome
Thank you, sir.
Dr. M.S. Rajgopalan, sir. He is the Professor and Chairman for ME Department for the Mechanical Engineering Department.
Thank you.
Of uh, welcoming Dr. B.V.N. Ramkumar, sir. He is the Professor and Chairman for Aerospace Department at DSU. Departments where there's a lot of demand currently coming in, and we expect that there's going to be a good information sharing from the aerospace department to all the students. I also take the opportunity of welcoming Professor Jasma Sangameshwara. She is the chairman for the Computer Science and Technology Department, where we have some beautiful programs on entrepreneurship and the development happening. So, warm welcome to all the speakers. And I would now like to request Honorable Vice Chancellor, sir, to take over and set the uh, activity or set the expectation plan for today. Over to the Vice Chancellor, sir.
Thank you, Ms. Shinde. Good morning to the faculty colleagues at Dayanand Sagar University and the students who are logged in, and also the parents who accompanied these students. Warm welcome to each one of you. The purpose of this interaction or meeting is to give you an update of two or three important components. The first component is to tell you briefly about what engineering is all about and what this pandemic situation is going to be. A little bit about the programs at Dayanand Sagar University, how exactly we are looking at framing the curriculum and framing the entire education at Dayanand Sagar University. Let me start with the situation that we are in today. You are aware of the pandemic situation across the world. The governments are doing their best to contain this pandemic situation to the extent possible. However, the context as India is because of the vast population, the measures that are being taken have to be accelerated, which governments are doing their best. And you are aware that there was a first wave in the year 2020. Somehow we could overcome that. And the classes were both offline and online, as far as the 2020 is concerned. Now we are into the second wave, where second wave seems to be a little faster than the first wave, more impactful. Therefore, all of us need to understand we need to overcome this second wave as well. And one solace is that these are temporary phases where we need to be courageous to face the situation and handle the situation. And is also being indicated there will be a third wave and a fourth wave, which may come in the future. Therefore, before that, all the countries are trying their best to vaccinate the entire population to reduce the impact of this pandemic because of the impact of the COVID situation. All that we request you to take the needed precautions and remember this particular situation is going to be a temporary situation. We need to overcome that. Definitely the good days are always ahead. With that particular note, we need to move on and plan future. And one thing that is very clear that we need to plan for our future because this is plus two. After plus two is going to be critical and crucial for shaping the careers of the students. Therefore, sincerely request all of you to take the needed precautions to overcome this particular situation. And let's be optimistic and let's hope everything will get over at the earliest. The second thing that I would like to touch upon is to bring you an update with regard to the 10 plus 2 board exams of ICSE, then CBSE, and the state boards. And so far it has been uncertain, and where the board exams have been postponed a little bit. Most likely, the board exams may happen in the second half of June or in the month of July. That's what it appears as of now, because the clear picture would emerge as we move forward. There'll be multiple board exams which we need to prepare, and I'm sure each one of you are ready. And let's hope the things would settle down and board exams happen at the earliest. After the board exams, I think there's entrance exam that you have to take to plan for your career in a professional courses. And possibly each one of you might have planned for some kind of career, either engineering or medicine or some other thing. And you also need to prepare for the multiple entrance exams like the JEE, the CET, the DSAT, and several others. Therefore, it's necessary for you to be ready with preparation for both board exams and the entrance exams. And one thing is more or less clear, the face-to-face classes may happen in an intermittent way in the next 1 year, because the entire situation may come under control after 6 to 8 months. That's what it appears, the complete control. Therefore, let's take all the necessary precautions to overcome the interim period. Coming to the engineering or the professional kind of courses, all that we need to understand is what does the future is going to be. There are multiple organizations which are making some predictions and giving enough inputs for the education institutions, the higher education institutions, to plan the curriculum, to plan the courses in a meaningful way, so that the students who are going to graduate from these higher education institutions get some gainful employment, get some gainful careers. Three or four uh, things that are coming in this. One organization which is named as the World Business Council for Sustainable Development. This is a more credible organization which has membership of about 200 global level CEOs from the PwC, the McKinsey, the Deloitte, the Harvard Business Review, MIT Technology Review, etc. All of them. All of them have normally sit together and they start deliberating and say what the future is going to be. How is the things moving? And they have come up with the following observations. One observation is that future of work or the uh, future scenario, job scenario, will be facing complex disruptions in because of three important changes. One important change is rapid technology evolution. Rapid technology evolution, there are a lot of technologies that are going to come up, thereby the technologies in the artificial intelligence, the machine learning, 3D printing, then several others. That's one major thing that's going to happen. The second major thing that's going to happen is the workforce expectations. The people who are going to work in a organizations, they want a lot more things from the organization. One such thing is the flexibility. They want more flexibility in working. They want more opportunities for growth. And this is the expectation of the workforce. This is the second important disruption that's going to happen. The third disruption that's going to happen is socio-economic polarization. Socio-economic polarization means the income inequality should go. Urbanization has to uh, be looked into. Climate change is another thing which is going to happen. Thereby, the entire future will be having lots of disruptions. Therefore, the people who are going to get into higher education institutions, particular students, the universities like ours, need to look into these kinds of things, need to note this particular thing. This is number one. Second, the future will have kind of jobs which are not existing today. Therefore, there are other changes being expected. What are the jobs that you see today? These jobs may completely vanish in the next 5 to 10 years. Therefore, we need to be prepared for that kind of a scenario. That's the other indication they have given. The third indication they have given is 50% of the jobs that we see today, they will be completely automated by AI, machine learning, the AR, VR, that's augmented reality, virtual reality, the mixed reality, and so many other things. Therefore, all of us need to be aware there is something which is going to be in store for the future. Therefore, it's necessary for us to be prepared. Therefore, education institution must be ready. The other thing that's been indicated by these organizations like the World Business Council for Sustainable Development, the World Economic Forum, and several others, there will be new age skills which are required. New age skills means the new kind of skills. New kind of skills are sense making. Sense making means if you are given a set of numbers, how do you make a sense out of the numbers given to you? Social intelligence is another skill which is required. Storytelling is going to be critical. Multidisciplinarity is the kind of skill that's going to be required. Then virtual communication means how do you communicate with each other on a virtual platform. What we are doing today is going to be the order of the day going forward. These are the kinds of skills. There are many, but these are the important ones. The other kinds of things that have been indicated in this by these forums is that 5 important skills are going to be critical for sustenance, for doing well in the future. One is the communication. Communication means how best you can explain a concept to a person who does not know anything about it. That's the kind of skill that's required. Second, collaboration. How do you work in a team? How do you contribute in a team is going to be another skill which is required. Critical thinking. Critical thinking is basically given a problem, how do you solve that particular problem? Because these problems are not being seen earlier. A new kind set of problems. How do you plan to look at these kinds of problems? The next is creativity. How you are able to solve the same problem differently compared to others. That is going to be the kind of skill that are required. The last thing that this skill that's required is the curiosity. You also need to keep the curiosity component in place all the time. Therefore, these are the kinds of things that are going to be there in the future. I am extremely happy to inform you that the the authorities in Dayanand Sagar University, the academia, the faculty in Dayanand Sagar University is fully aware of these kinds of skills. Therefore, it is necessary for each one of us to understand. The other thing that's also been indicated in the future is that there are 8 technologies which are going to dominate the future. The first technology is going to dominate is robotic process automation. Majority of things are going to be done by robots. That's one thing which is going to happen in the future. Second, the industrial robots is going to be the order going forward because they're going to use the IoT, the sensors, the etc. Then artificial intelligence is another thing which is going to dominate. 3D printing is the thing which is going to dominate. Quantum computing is going to become a dominant technology. Android robots is going to be another technology is going to come in. Then the connectivity, 5G cellular technology is going to be the technology is going to dominate. The next one is digital currency, the kind of currency that we are having using blockchain and those based cyber security or cyber currency will be the order of the future. When I say all this, more or less it appears that all of them towards computer science. Definitely not. Please understand the technologies that are going to be used are going to be used by everybody, every engineering student, whether be it mechanical, electrical, then civil, they're going to use these technologies because all these technologies are going to be learned by everybody going forward because the kind of job that are going to be done in the future are far different. Therefore, multidisciplinarity is going to be the key. Now, last thing that I would like to touch upon is that the kind of jobs that you're going to see, where these problems are going to be, where these jobs are going to be. The jobs of the future are going to be in the area of providing food and shelter for the entire growing population. Therefore, food production is going to be one of the key things. It requires the technology, it requires all kinds of studies. Maybe a student with management skills are required, student with computer science is required, students or the graduates with mechanical engineering background are required, agricultural background is required. Actually, there's one place where a lot of jobs are going to be created. The second is the healthcare. The kind of healthcare that's going to be there in the future will be far different from the healthcare that we have today. The kind of problems that we see today for the pandemic, these problems may not be a serious set of problems going forward, maybe in the 5 to 10 years, because a lot of predictions can be done, a lot of preventive care can be taken. Therefore, that's another area, a lot of jobs are going to be created. The third job that's going to be created is the connectivity, providing the internet connectivity, the road connectivity, the rail connectivity, the air connectivity. That's another area where a lot of jobs are going to be created. Then there are a lot of computing power required. Therefore, it requires a lot of jobs are going to be created in the creating computing power. Then finance sector is another area where a lot of jobs are going to be present. Then there's a lot of privacy kind of issues that are going to come in. Therefore, a lot of work is going to be done in the providing privacy-enabled technologies. Then climate change is another area where a lot of jobs are going to be created. Climate change involves a biology kind of a person, environmental kind of person, mechanical, civil, etc. Everybody is going to be involved. Then faster construction technology is going to be the kind of area where a lot of jobs are going to be created. Therefore, all that I would like to say that the jobs are going to be there in every discipline, irrespective of the kind of brand that you're going to take. Therefore, we have to have no anxiety. Only important underlying thing that all of us need to remember is that the the student interested in doing a particular branch of engineering can go ahead and do that. Jobs are going to be there for everybody across all sectors, management, then law, engineering, etc. Therefore, with these few introductory remarks, I would request my colleagues to tell you about the program that we have at DSU and the career opportunities for each of these branches going forward. Then we will take the questions at the end of the session and answer some of the queries you may have. And thank you for a patient hearing. I request the next speaker to take over and present the kind of courses that are being offered at Dayanand Sagar University.
Sir, thank you so much. It was really a good moment for all the students to take a note, especially in terms of kind of technologies that you mentioned in the areas of robotic process automation, artificial intelligence, machine learning, 3D printing, quantum computing, talking about Android robots, 5G technology, digital currency. These are the upcoming areas where students who would now like to look at engineering as a career can think about. Thank you so much, sir, for the information given to them. I would now like to invite Dr. Sanjay Chitnis, Professor and Director for Innovation and Entrepreneurship, as well as the Chairman for the Computer Science Engineering at DSU. Sir will talk about the overall in terms of the engineering as a career. Uh, Over to you, sir, and I'll do this. I'll stop the screen sharing, and screen sharing access will be given to you.
Yeah, sorry to interrupt. I request Professor Vaibhav actually to.
Okay. I would request Professor Vaibhav,
Sure.
sir, will give you the screen sharing.
Screen is visible, sir?
Yes, sir. You can go to the slideshow and show it, sir.
Sure. Just a moment, sir.
Vaibhav, make it full screen.
Yes, sir. I'm again full screen.
Yeah.
Is it visible, sir?
Yes, sir. Please go ahead.
Please go ahead.
Yeah. Good morning to all of you, my dear students, parents, Honorable VC sir, our Shinde sir, and all the chairmen of the department. On behalf of our Dean sir, Dr. Srinivas, will be presenting first year BTech orientation opportunities, expectations, and regulations. So to start with, we have in our Dayanand Sagar group of institutions, we have a 3 institute: Dayanand Sagar College of Engineering, Dayanand Sagar Academy of Technology and Management, Dayanand Sagar University. Most of the parents, they come to us for the counseling. They have a confusion. Sir, I got a score. Can I get admission in Dayanand Sagar College of Engineering? Can I get admission in Dayanand Sagar DSA, Dayanand Sagar Academy of Technical and Management? To make you clear, we are Dayanand Sagar University, different from Dayanand Sagar College of Engineering and Dayanand Sagar Academy of Technology and Management. Dayanand Sagar College of Engineering is autonomous VTU. Here the degree is given by the VTU. All the exams and syllabus and all paper setting is done by Dayanand Sagar College of Engineering. And in Dayanand Sagar DSATM, it's affiliated college to VTU, Vishweshwarya Technical University. The degree is given by VTU. But in case of our Dayanand Sagar University, we are a state private university. It's a degree from our side. It's a degree from the Dayanand Sagar University. So it should be very clear that Dayanand Sagar College of Engineering is separate, DSATM is separate, and Dayanand Sagar University is separate. We would like to take questions at the end. And there will be a lot of questions that, sir, Dayanand Sagar University, the DSATM, DSCs are the same. No, they are different. We have We are a state private university. We offer our own degree. And I will, in the future slides, I will tell you about the curriculum about all this. So we have a campus. We are placed at Kudlugate campus. We are School of Engineering. We have a Kumar Swamy Layout campus. All this is under Dayananda Sagar University. We have a School of Basics and Applied Science, Schools of Commerce and Management, Schools of Health Sciences, Schools of Arts and Humanities. And at the Haroli campus, which is a big campus, which is around 150-acre campus, we have a Dayanand Sagar Institute of Medical Education and Research. We call it as in a short, we call it as a CD Cymer. It's a medical institute. The first batch of the MBBS had already started here. And dear students and parents, you can see how the multidisciplinary approach we are having here. An engineer student can go to the medical and can do a project in the medical field. A medical student can come and talk to us about some requirement related to them. In this way, we are, as a university, we have a multidisciplinary approach. We are interdisciplinary. Okay. So then our university governance, we have a Chancellor, Dr. Hemchand Sagar, Pro-Chancellor, Dr. Premchand Sagar, Vice Chancellor, Dr. KNB Murthy, Pro-Vice Chancellor, Professor Janardhan, and a Registrar, Dr. Puttamadappa. We have 4 campuses, as I mentioned earlier. This is a Dayanand Sagar College of Engineering, which is at Kumar Swamy Layout. It is our School of Engineering campus, which comes under Dayanand Sagar University. It's at Kudlugate. We call it as the campus number 3. We have a DSATM, totally VTU campus. It's at Kanakpura Road near Sri Sri Ravi Shankar Ashram. And we have a university setup at campus C4. We call it the Haroli campus. We call it the Haroli campus, where we have a medical institute. Faculty strength in any university, the emphasis is on the faculty strength, how good the faculty is there, how good the innovative the faculty is there, how supporting the faculty is there. Keeping that in the back of mind, nearly 60% of the faculties in Dayananda Sagar University, specifically in the School of Engineering, are having a PhD from a premier institutes, from IITs, from RECs, from ISCs, and from the institution abroad. Faculty with a good mix of academic, industry, and research experience. Let me tell you, the chairman sitting here, including me, are having 15 plus years of experience in the industry. All the chairmen sitting here, we have 15 years of experience in the industry, and then we have come to the research. All the faculties are ready to change because engineering education is not a stagnant one. We need to keep a change with the time. We need to inculcate some artificial intelligence component, some machine learning component into our curriculum. So we should be ready for change. And if you are ready for change, then only we'll be able to tell our student that's something good. Curriculum design, which is a very important aspect in a university setup. In this, I'm not saying something wrong about any VTU or any government universities, but a private university have this freedom to design their curriculum. Of course, how it is designed, I will tell you, to design their curriculum as per the need, as per the industry need. So we have a department academic committee for designing a curriculum. Suppose I see that some new courses are coming related to some PLC or SCADA or some machine learning. I have a freedom after consultation to include it in my curriculum. And for that matter, for any branch in the School of Engineering. We have board of studies. It is not that curriculum design I like and I put it some courses I don't like, I remove the courses. No, it is not like that. There are board of studies comprising academicians from premier institutions like Indian Institute of Science and from the academics. We all will sit together. We'll see that whether this course is required, whether there is a need of a time. And that is the beauty of the universities. That is the beauty of Dayanand Sagar University, the private university. We have a flexibility of designing the curriculum. We have a flexibility to include the courses. We have a flexibility to add, we have flexibility to have a lab integrated courses so that more and more hands-on experience our students should get. We have a board of examiners where the papers, since we are the university, we can set up our question paper, but it is not like we can set up at whatever we like. We have a board of examiners where we will invite external faculties to scrutinize our paper, and we will see whether it is following the Bloom's taxonomy or not. We have academic council. After all the syllabus finalization on, it will go to the academic council and board of governors for the approval. So this flexibility of designing the syllabus in the university is a very beautiful thing that had come up in any private university. Design philosophy. In the design philosophy, how the courses are designed, any courses in School of Engineering, how the courses are, first of all, there is a engineering science core courses. We cannot forget our physics, chemistry, maths. We must have that thing. So some weightage is given for that. Then we have departmental core courses. I'm from the electronics. So we have a departmental core courses like electromagnetic. Student will say, sir, electromagnetic is tough subject. Can we remove it? We will say, no, it is a core course. It must be there. Then there are the department electives. We will guide our students. We'll guide our students to choose a department electives. So at least they can get some specialization in particular that domain by selecting the department elective. Theory integrated, as I mentioned earlier, we have a theory integrated with a lab in majority of the courses. It is not like a normal curriculum. We do first experiment, second experiment, 10 experiment done. It is not like that. The module is taught with the module. Simultaneously, we'll be having a hands-on experience with hands-on session for the lab, so that theory cannot be forgotten. It is said that doing we will remember the more. Doing by doing we will remember more. So we will have a lab. We are having the lab integrated courses. Another one is a very important thing: institutional electives. Our students can select some of the courses from other branches of engineering, like it may be a computer science, computer science, or mechanical engineering, or electronics engineering. So electronics engineering student, I mean, that can select courses from some other branches of the engineering. Going ahead, we have a vision that student must be student, as we are a university. Students are free to select the courses from some medical background, some arts background, some commerce background, so they can get a knowledge into that particular. We have a mini projects and a minor projects. Mini projects and minor projects, I will talk in the subsequent slides. If any questions you have, you can put it in the chat boxes, or you can interrupt me anytime. Best practices. Since we are the private university, we have a choice to have, create some best practices. Best practices. The first one is we have 2 credit project-based courses from 3rd to 6th semester. To see that all the students are getting hands-on experience. We are starting the projects from 3rd semester itself. As you are aware, the 1st semester will be the foundation courses, physics, chemistry, but there are also the hands-on component are there. But when they come to a branch from 3rd semester onward, we have a 2 credit project-based component. Active learning, hands-on lab component in the core course, as I mentioned, lab integrated with the courses. Open-ended experiment. After doing some experiment, it is not 1, 2, 3, 4 like 10 experiment. After doing experiment in that subject, we will give the open-ended experiment for them, so they can go search wherever they like, and they can come up and submit the report. Summer internship. Now, since the pandemic is there, so we don't have a summer holidays and all this thing. But when the offline classes were going on, we were having the summer internship, because there is a quite a number of days or holidays are there. So around 2 months holidays are there. So student can come to the campus and do some summer internship, and they can gain some knowledge under this thing. Moodle-based learning management system, which is very important. We call it as a learning management system, where all the notes, all the lesson plan, all the subject-related notes, all the assignment will be uploaded there, and student can read it any point of time. All the recorded lectures will be uploaded there. Student can see at any point. By chance, some student is missing the lecture, he should not repent. He can go to that and he can see the recorded lecture. He can. So we don't want student to miss the lecture, but by any chance he is missing, he can go to the Moodle LMS learning management system, and he can see the lectures. Student internal test, another important criteria. Marks and attendance trigger to the parents. E-governance system we had adopted here to trigger a daily SMS to the parents on missed classes. If students are not coming and they are absent, automatically at evening 4:30, a trigger will go to the parent that your son or your ward was absent today, and then we will take a action on it. E-governance will trigger test marks communication to the parent. Even the test marks that are being conducted will be sent to the parents via SMS or via email. BTech program differentiators. As a university, we have 2 differentiators. So students earn a BTech degree with 160 credits. We have a computer science engineer. There are total 160 credit. Credit system, I will explain you further what is the credit system. Usually, one course, and roughly I'm telling, one course have 4 credits. So on an average, in a semester, there should be 8. There are 8 semesters. On an average, there should be 20 credits per semester. On an average, I'm telling you, there should be 20 credits per semester. So at least 5 courses should be there. So what are the branches? Computer science and engineering, electronics and communication engineering, mechanical engineering, aerospace, computer science and technology. Specialization degree in the CSC we have with 160 credit, AI and machine learning, cyber security, data analytics. Okay. Okay. In EC, as I told you, we can select a department elective in such a way that student get little bit specialization into embedded system, VLSI and communication, because in our EC domain, we have an embedded system, VLSI, so proper choice of a department elective can get extra knowledge into the embedded. They will get overall knowledge, but some extra knowledge into the embedded system. It again depends upon the student's interest. It again depends upon the student interest, and of course, faculties are always there to guide the student that you move in this direction, your interests are in this direction, choose some department courses so you will become expert into the embedded system. And why this is required, I will subsequently tell you. In the mechanical engineering, we have a specializations, robotics and automating. So elective courses can be selected in such a way that they can get some specialization. They can get specialization into robotics and automation, advanced manufacturing, green energy systems, emerging automotive technology. These are all the emerging technologies. In the aerospace engineering, we have aircraft structures, advanced aerodynamics, and avionics. They will specifically, the chairmen of the particular department will be speaking in detail about this thing. The very interesting concept in our universities, minor across a domain. That means what? If a student is doing BTech major in computer science engineering, ECE, mechanical, CST, or aero, as I mentioned, it's a total 160 credit course, or an average 20 credits per semester. Then what is minors? Then he can do a minors across the cross discipline. Suppose I am a student of EC. I can take an extra credit and do a minors into computer science engineering. I am an electronic student. I can do minors into mechanical engineering. I can do minors into computer science technology. I can do minors into aerospace, which can further be extended to the mechanical, which can further be extended to MBA courses and all. Major and minor initiatives, so optional. So and it's not forced, it's an optional. If the students want to do it minor, welcome. If you want to do a major, if you want to do a minor, he's welcome to the minor. It is not forced. It's again depend upon the student interest. It is apart from our regular credit, my dear parents and students, it's apart from our regular 160 credit. So students are a major degree in a chosen discipline. I had chosen my branch as electronics and communication engineering. So this is my major degree. A student can earn minor degree in a cross discipline through additional 20 credits. So that means additional 20 credits. As I told you, on an average, 4 credits courses are there. And these are all hands-on lab integrated courses. It is not just like come, go, theory and teach. No, these are the lab integrated courses. These 4 courses, that is a 12 credit courses, are lab integrated. We will have a hands-on experience. A student can earn BTech degree in electronics and communication. He can register for additional credits in computer science and earn minor with the following courses. Suppose a student in electronics and communication engineering is there. If he does some 12 to 18 credit extra, he can earn a minor degree into a advanced object-oriented technology, data structure, database systems, analysis and design of algorithm, operating system. So you can go ahead and say that I have a degree in electronics and communication with a minors in computer science. I have a degree in electronics and mechanical engineering with a minors in computer science. I have a degree in computer science engineering with a minors in mechanical engineering, because going ahead, as our honorable VC sir had mentioned, the approach will be multidisciplinary. Even new education policy 2020 emphasized on multidisciplinary and interdisciplinary approaches. And going ahead, I will be telling you that the projects that have been done in our SOE are keeping in the mind that it should be multidisciplinary. Major in a CSC, that's it. I told you, major in a CSC, EC mechanical. So minor aero, minor mechanical. We have minor in EC, minor in CSC, minor in entrepreneurship and innovation. Modalities. Now, what are the modalities of this minor and major? What is the modalities of minors? Course including lab. As I told you, all this course includes lab. Done during the summer semester or after the hours during. We will not disturb your regular semester activity. Either it will be during the summer term or during the after hours. We will get a separate grade card with the course and grades mentioned in it. The minor is entirely an optional and not linked to the regular courses. As I mentioned earlier also, it's optional. It's a totally optional for the student and it is a not forced activity. The individual courses requirement for minors are same as that of the regular courses. Okay. Now we have one more concept. One concept is major. That means you have a degree in electronics and communication. Minors you can take either in computer science, aerospace, and mechanical, and so on. We have one more concept called BTech honors. Student can earn honor degree by earning 18 credits. And for that, they have to attain some online courses or some department specified courses. The online courses they can attain from MOOCs, NPTEL. Of course, it will be monitored by the faculties. Coursera, Udemy, EDC, and Swayam. Student feedback, very important concept is that we work on a feedback system where we will regularly collect 2 online feedback sessions from e-governors. Faculties, it's collecting a feedback is not any fault finding exercise, it's a fact finding exercise. Faculty to get opportunities to implement the student needs to the feedback. So it's not something like a fault finding, it's a fact finding where the faculties will also improve and students will also get benefited out of it. So both the parties are getting benefited. It is for mutual beneficial. Dean, face-to-face feedback. Dean also goes to some of the classes, almost all of the classes, and he will also take face-to-face feedback about how the things are going on, whether the faculties are on time, whether the faculties are covering the curriculum as per the lesson plan, whether the board of studies, academic and industry, we will take a continuous, Okay. Qualitative feedback with Dean's present section. Students openly express their concern to the Dean. Chairman and discuss with the teacher, and then it will be documented. And faculties will be always tell to improve on that thing. Follow up done with the various stages to certain the improvement. And as I told you, it is not a fault finding exercise. It's a fact finding exercise which is beneficial to all the stakeholders. Continuous improvement. Continuous feedback from board of studies, academic and industry. We will also take a continuous feedback from student feedback from the e-governance. There is alumni feedback. It is not that we will take a feedback from the alumni also, that how are they stay here, how are the course content, whether it need to be improvement. And in board of studies, we have an alumni member also. Apart from the dean face-to-face feedback. Now, the very important thing is assessment. How the assessment is done for the student. There are 2 parts here: continuous internal assessment and semester end exam. So students may come across this terminology SEE. Student may come across the terminology CIA. We call it as in short form CIA. We call it as in SEC. So we have a continuous internal assessment for 60% mark, and going ahead we may go to the 70% also. And we have an end semester exam for 40%. So continuous, we want student not only to write and write and write. We want them to learn. We want them to learn while doing some projects. And for that reason, we have one mandatory test, one sit-in mandatory test. Another one is a computer-based test, so they can get acquainted with the computer, how the tests are when they're going for some interviews and all these things, how the tests are conducted. They should. Apart from this thing, from these 2 things, these 2 written tests, we have other components in the CIA that are assignment with Viva. Not only that, submitting the assignment, copying and submitting the assignment. We tell a student that we don't have a problem in you copying the assignment, but you must answer the question. If you're not able to answer the question, please go read it and then come back. We have quizzes, we have mini projects, we have hands-on workshop, we have research paper presentation, we have industrial visit, we have reflection notes from the experts. And for these, again, it varies from subject to subject, but these are few components that it's again a freedom given to the faculty to design the CIA component, but 2 mandatory components are there here: sit-in test and computer-based test. Apart from this thing, they can choose any after 5, 6, 7, they can choose any 3, 4, and they can plan their CIA for the 60 marks. Remaining 40% marks are about the semester end exam. That is 60% continuous internal assessment and SE for 40%. For the first time at DSU, we have programming related semester end exam has a major lab component. Students, it is like student spend first 2 hours on the paper, and then they have to get up, go to the computer and solve the problem. Very critical for today's session, that some problem is given, you first solve the problem. Whenever the problem is given, write down the problem, solve the problem, whether the output is coming or not. Let us go and verify it on the computer with the help of a simulation or with the help of some program. So 2 hours paper, remaining 1 hour, whatever you have written, you have to simulate it and show the result. You have to write some program and show the result. This is much needed in today's scenario. When you go to the industry, my dear student, when you go to the industry, some problems will be given. You will not directly go to the computer and solve. You have to note it down, what are the steps are there, what is the algorithm is there, what is the formula need to be applied, which languages are need to be applied, and then try to simulate it. It is not that directly go to the jump on the computer and start solving it. We follow, as I mentioned, we follow the Bloom taxonomy while setting up the paper. The Bloom taxonomy is 6 level: remembering, understanding, applying, analyzing, evaluating, and creating. This is the Bloom taxonomy. Okay. Grades, we have depending upon the performance of the students, they can get an outstanding grade. We don't want anybody to get a fail F grade. We don't want anybody to get P or pass grade. We want all of you to be in this range, O, A plus, A. So O, outstanding, it's a 10, A plus 9, A 8. Beyond that, we should not think also. My dear student, below this, we should not think. Okay. These are the SGP and CGP calculation, which are not much required. Okay. Now we have to take care of your CGP from the very beginning only. You have to maintain the CGPA preferably of 8, so that tier 1 and tier 2 companies that are coming will ask the CGPA of 8. And for higher studies also, when you are going abroad for MS and all this, they will ask the CGPA of 8. For that, you have to maintain it from the very beginning only. It is not that I will work hard at 7th and 8th semester and I will make up with a CGPA. No, it's not. You have to maintain. Of course, you will be guided by the professors and the mentors. A good lesson to learn. If a CGPA is in first year is very low, it is, as I mentioned, if it is very low, it is very hard, dear students, to pull it up in a later semester. First semester 5 CGPA, second semester 7.6 CGPA, and then some second semester 6.3. It is very difficult to come to the level 8. So from the very beginning, from the first semester itself, you have to work hard. Of course, you will be guided by that. So watch out on the SGPA and CGPA every semester, right from the first semester. It is not like that 5th semester I will start earning, 6th semester I'll put effort. No, it should be from the first semester. CGPA not only shows your percentage, it shows your efforts in learning. CGPA not only shows your percentage, but it shows how much efforts you had put it in learning. So you can't say that 5th, 6th semester and 8th semester I will put more efforts and I will know. Learning should be from the first semester onwards. Promotion to the subsequent year. This is a very interesting thing that student can seamlessly complete 4-year BTech courses, a big change from the previous year. But there is one catch here. There is one catch here. Student can throughout go from first semester to the 8th semester. Earlier, there was some, if you are not clearing first semester, you cannot go to 4th semester. And there was so much, this thing were there. Now, student can seamlessly complete 4-year, but there is a catch here. There is a catch. What is that catch? Concept of prerequisite. Suppose you wanted to take as I told you that you can go from seamlessly from first semester to 8th semester. But if you want to take some subject which is in 7th semester, and if you have prerequisite for that in 6th semester, you must clear that 6th semester course before taking that 7th semester subject. That is what written here. Prerequisite will be specified for a few courses and elective courses. There is no year back in any case. We don't want a student to lose their precious year. 1 year lost in life is a big thing. We don't want our students to lose their 1 year, but at the same time, there is a prerequisite also. Attendance, a very important concept in engineering. Engineering is not something which can you come and go and not attend the classes. 85% mandatory attendance is there. All students will be detained if the attendance is less than 85%. Our experience in the teaching tell us that if a student is attending regularly classes, chances of him getting a CGPA less than it is very less. Very less. That's why it is mandatory to attend classes. Try to maintain attend 85% is the minimum, but try to attend 100% classes. The student has to repeat the courses in the summertime in case of detainment, but this situation we should not discuss, and this situation should not come to any student. An open platform. E-governance and Modalities only. It is a learning management system. Okay. Role of a mentor, as I told you earlier also, we have a mentoring system here where the mentors will be guiding a student to which electives they have to take, which institute elective they have to take, in which, what are the extracurricular activities are there. Some students are very shy. They may not come forward. They are maybe a good singer, but they are not coming forward. Mentor will help them. Mentor will groom them to come forward in the life. Mentor will see what are the good things into the student. If there cannot be any bad thing, but if any something is missing, he can tell the student that for this thing you are missing, you must attend this. If suppose some student is not good in a communication, a mentor can tell him that read these lectures and try to improve your communication, try to improve your English. Maintain a good communication. This mentor during this pandemic, this mentor role had come into this mentor role was very, very important because we were continuously interacting with these students. Students were sitting at the remote places. Somebody was having an internet problem. Somebody is having some electricity problem. Somebody don't have a laptop. Somebody don't have some 4G connection. In this case, students were directly in touch with the mentor, and it had worked very well. Specifically, mentoring system works everywhere at all the time, but during this pandemic time, it was a moral support for the student. It was all the students, most of the students, those who were in the home, they were not accessible to the faculties, they were not able to see the faculties and all. They were entering into the different mode only. So it is where the mentor roles come into this, and they were taken out of this. Integration, as I told you, integration of a mini project with the innovation lab. We have a And as I told you earlier, also there are 2 credit mini projects from 3rd to 6th semester, and these are integrated with the innovation lab. Every department, aerospace, electronics engineering, computer science engineering, our innovation labs today. Research opportunities for the students. These are the innovation labs: Bosch Rexroth, Bosch ETAS, Autodesk Innovation, IBM. So Bosch ETAS and Bosch Rexroth, Bosch ETAS is specifically related to the electronic. Bosch Rexroth is related to the mechanical, but our electronic students are also involved there. As I told you, it is interdisciplinary. Autodesk Innovation Lab, IBM Software Lab, VMware, these are specifically related to the computer science, NVIDIA, GE Healthcare. Analog Devices Lab, specifically related to our electronics and communication engineering. So our students are doing some mini projects, and these mini projects are associated with these innovation labs. These are the various innovation labs at our DSU, specifically at School of Engineering, NVIDIA, ETOS, Autodesk, VMware, and this. You can when you will be coming to our campus, that the Kudlugate campus, we will definitely take you to this lab, and we will show this labs to you. Offerings in the innovation labs. There are in the these are the various companies that are in the innovation lab. Offerings in the innovation labs are certification courses, or project-based learning. Your student can do the internship. Why to go outside when we have such beautiful labs at our campus? We can do internship there. After doing internship, some students are interested in developing some product and R&D. They can also, if suppose these industries are given like analog devices, they are giving some problems. Our students can sit and solve the problems. So these are the offerings of the innovation lab. Training. This is a very important part in an engineering curriculum. Workshops are conducted based on IoT, Python, which is a upcoming technology, and IBM Cloud, Advanced C++, data sciences. Again, we keep our industry partners in loop into all these things. We will ask what is the requirement, whether Python is required, C++ is required. So industry friends and industry board of studies member and industry friends will tell us, oh, now the trend going is Python. So we'll let us start training our students on the Python. Somebody will say C++. Let us start training our students in the C. So it is in a entrepreneurship, very important. Attract a high quality entrepreneur, venture for incubation. We have a Derby. Okay, Derby slide is okay, fine. Yeah, entrepreneurship. We encourage our student to become an entrepreneur. We have a Derby setup in our Kudlugate campus. Undergraduate Research Forum. Research are the activities that are not to be started at a postgraduate or PhD level. We think that research are the activities which can be started at the undergraduate level. For that, we have set up a research forum, a center which administers the UGC research as a formal body, carry out innovative projects, set up a makerspace lab, identify domains that are current in various engineering, define a set of projects. Okay. As I told you that during the summer, we have a summer term internship here. Our students will do a 7-week project-based summer internship. And it is from across the department. It is not that, and it is across the department, it is across the years also. It is not that you are in the first semester, you cannot come, you are in the second semester, you are in the final year, you can come. It is across the semester and across the department. And this is the activity driven by our Dean, Sir, Dr. A. Srinivas, and quite an interesting project had come up into that. LIDAR-based, Wi-Fi based smart lighting, interactive robotics, IoT-based projects, AI-based project, machine learning-based project, blockchain and all. As Honorable VC Sir had mentioned, these were the projects that our students had done: blockchain, artificial intelligence, IoT, robotics, and all this. Okay, so staircase climbing robot and all this thing. Consultancy, we have a consultancy project, we have a industry sponsored consultancy project. So there is active collaboration with the industries and organization. Dr. Amarnini Rao has set up a water technology and research lab, which is a much needed, which we had seen the purification of the water and what level it had got, and that for that reason we have a water technology and research lab, which will change the hardness of the water if any fluoride content is there in the water. And it is from the Eureka Forbes, a very well-known company which is in the water purifier. Domain groups, these are the very important domain groups. Under a domain head will be there. Under domain head there are the faculties, and under the faculties we have a UG and PG student. Domain head in the sense, as in case of electronics, I can tell you that there are specifically 3 domains in our department: VLSI, embedded, and communication. Mentors and the domain faculties will guide a student to select the electives in that direction. We'll see the interest of the student, and accordingly we will align the student into that domain, so that they can do a good projects, they can do a good presentation, they can file a patent also.
Sorry, in the interest of time, we will have another 5 minutes more.
Yeah. Yes, I'm done, sir. It's quite interesting. So in the CSE, we have domain groups from network and IoT, big data, cloud computing, cyber security. In ASE, electronics and communication, we have VLSI, embedded system communication. In mechanical, we have material, very interesting electrical vehicles, which is now the renewable energies and robotics and automation. This is a case study. Okay. So finally, in our SOE, our learning is totally based on projects. Reading a high quality. One second. Simple tips are here. Reading high quality textbook. Don't go for some local type of notes and all this thing. Writing habit on a regular basis. General reading on a regular basis. Discussion with the teacher on regular basis. Develop a joy. This is very important. Whatever you learn, it must be joyful. If there is no joy, there is no learning. Develop an excellent attitude. Attitude is very important. Students and books. And finally, it's a projects, and only projects. Key to success: hard work, honesty, and integrity. These are the key to the success. Apart from our regular, just all I had spoken about technical, this subject, that subject, but is there something apart from our regular studies and all this thing? Of course it is there. We have Astria Club, we have Computer Society of India, we have Mathematica, we have Magic Nemesis, we have Satellite Club, we have a IEEE Club, and on the cultural side we have Abhinaya Club. Someone good in acting and all this thing can definitely register into this thing. Fine Arts Club literally comes very good into writing, and somebody is very good into writing, they can register into this. Music Club, NSS, sports. Without the sports, how it can be without the sports? It's incomplete. How can we ignore the sports? These are the key students' achievement, which is specifically, we will say that our approach is a multidisciplinary approach. So a student from electronics and communication engineering and mechanical engineering had come together for a project, that is solar paint, which was done at ARCA, Advanced Research Center for Powder and Metallurgy. It's located at Hyderabad. Again, the students of electronic and mechanical engineering come together, and they had done a good project at the National Institute of Wind Energy, Chennai. One batch of EC students carried out a project at Defense Avionics Research Lab and Establishment, and that is LRD. In the mechanical, student participated in Tiffan, Technology Innovation from Agriculture Nurturing, Onion Harvester Competition, and they had won a prize also there. Excellent. Key student achievement, 6 students of 4th year got selected for placement in Japanese company with a pay package of 20 lakh per annum. Student meetings are Nobel laureate. In our lifetime, we won't get an opportunity to meet a Nobel laureate, but our students had a face-to-face meeting on 11th March 2019 at Raman Research Institute. He's a person who got here is our Dean sir is there. He's the person who got a Nobel laureate in the Nobel Prize into chemistry. Our student happily smiling and interacting with this Nobel laureate. In my lifetime, I didn't get an opportunity to meet a Nobel laureate, but students met this Nobel laureate, had a very nice time with him, had a discussion, and it was interesting. This just to show. Student internship at various companies. This I will not take. These are the placement 2019 batch in computer science. There were registered students were 82, eligible were 65, and placed were 114. These 114 includes double. Some of them might have got 2 jobs also. In electronics, 65 registered, 45 eligible. You may say that, sir, there are so many students, why 82? And some of them are not interested in the placement. They may be interested in going to higher studies, or they may be going for MBAs and all these things. They are not interested in placements. So this is the 2020. In the 2020 batch, we have registered 158 students, placed 173. Again, there are double here. Electronics communication, 89 were registered, 67 got placed. Almost all the eligible students have been placed. The list of the companies for the computer science. This is the data from the placement department. These are the list of the companies from the computer science department. From the electronic and mechanical as well. Mechanical, we have Accenture, Amazon, Access, Cognizant, IndiaMart, and so on. Discipline is very important. Discipline is very important in our university. There is a zero tolerance for indiscipline. No mobile usage on campus in working hour. Main gate closes between 9:30 to 1 a.m. Student can't enter after 9:30 p.m. We have to be disciplined. Students, as a student, you must be disciplined in your life. Student can't leave the campus before 1 p.m. No torn jeans, collarless t-shirt, like casually coming on the bathroom chappals and torn jeans and low waist
We can skip
jeans
this
are there
slide, sir.
nowadays with something. Okay. Adverse effect. Okay, these are the.
Sir, we can skip this.
Okay. Yeah. Okay. Thank you. I hope I had covered most of the points here. Thank you.
Stop the
Because
screen
of the
sharing.
time constraint, I
Give me
could.
the access of screen sharing.
I'm stopping sharing. Sir, 1 second. 1 second.
Yes, sir, please. So thank you so much, Vaibhav, sir.
Yes, sir.
Pleasure interacting.
Thank you very much, sir.
It was a pleasure for all the students to know the overall aspects in terms of the careers in engineering, and it overall gives an idea to the student in terms of how he can move forward. I now we will move on to the next session. We will now be looking at the careers in aerospace engineering, and I would like to take the opportunity of inviting uh, Dr. B.V.N. Ramkumar, sir. He is the professor and chairman for aerospace department. Over to you, sir. I am doing the I'm giving the screen share option to you, sir.
Thank you. Are you able to hear me?
Yes, sir. We are able to hear. You can go to slideshow. Yes, sir.
Good morning. Good morning, all. Thanks for joining today. I'm really excited to speak with you. Especially my talk is majorly is limited to the Department of Aerospace Engineering. As a professor, Vaibhav already has discussed about the university and various programs. I'm not really touching those things. My intention for the present discussion is on the aerospace engineering. Here, I'm trying to give you some overall idea about what is the aerospace engineering, what kind of the curriculum we follow, and where are the opportunities we will get as a aerospace engineering, and something about the career path. Okay, with that, let me go ahead, start with that. About the aerospace engineering, it's an upcoming and exciting field of engineering. You all know that it's kind of the engineering people with a lot of fantasy. They will select the aerospace engineering. As you all know that uh, major innovations and discoveries are happening through this field of engineering. So I can say this is a place for innovations and discoveries. People, students with a blend of innovation, I feel they can prefer the aerospace engineering. What it deals with, aerospace engineering, it deals with the development of aircraft and spacecraft. Generally, many people have the doubt. Generally, they get confused between the aeronautical engineering and aerospace engineering. Aeronautical engineering mainly deals with the vehicles which can travel in the air. That's something related with the aircraft. Whereas in the aerospace engineering, it covers the aeronautical engineering. On top of that, it deals with the vehicles which go beyond the air. So something like space, where there is no air. So aerospace, it contains the two words, aero and space. So aerospace engineering is a very broad one, which covers aeronautical engineering and astronautical engineering. Generally, people say astronautical engineering. Astronautics is dealt with the astrology, basically, planetary system. So aerospace engineering, it covers both. Aerospace engineering covers aeronautical and astronautical. Okay, in the course of aerospace engineering, we do many fundamental courses and domain-related courses. I just kept some of the things which we deal from the Dayanand Sagar University. Our courses will start from the basic sciences, then with the core engineering. In the core engineering, we cover the materials and manufacturing. Next one is the design and analysis. That's the really need of the day. Probably people could have heard about the digital twin, then virtual testing or simulations. In Dayanand Sagar University, we are really proud that we have the very great system for the design analysis. We have collaboration with no, big giants in the industry. And we started Center of Excellence in Dayanand Sagar University. Probably you could have heard about the Rafale, the manufacturer of Rafales. Uh, that's the company we have the collaboration basically. So we are really strong in that. And to just give you some idea, one of the students from the 4th semester, he got internship from the Autodesk, basically. Presently he's in fourth semester, but still because of his skills, he got the internship and it's kind of the paid internship. So while studying itself, he started earning. That's really proud moment, proud moment for all of us. Actually. So this is the major thrust what we give in the Dayanand Sagar is on the design and analysis. Then we will cover, our curriculum will cover something about the testing and certification, then the maintenance, repair, and overall product development. It's we give more priority for the aero components, but at the same time, the syllabus what we cover, it covers the both in general and the aerospace product design and development. Then we also give priority for the system engineering. That's the need of the day. That's the systematic way of developing the products, system engineering. Apart from that, we have the subjects for the supply chain management and aftermarket support. Then you all know that aerospace engineering is a kind of the interdisciplinary and multidisciplinary discipline. Apart from these core related subjects, we also give a lot of priority for the computer-based subjects, as VC sir has mentioned you. Nowadays, everyone needs to understand about the new technologies like IoT, data science, machine learning, artificial intelligence, and then AR, VR. We have the separate subjects for those things, which gives the priority for the domain related thing. Apart from that, programming related things they can learn from the computer science department through open electives, institutional electives, and at the same time, mini projects. So we have a lot of flexibility in learning all these things. And apart from that, we have this separate club activities where we encourage the students to participate and improve their hands-on experience and participate in the lot of competitions. Okay, after learning something about the what we cover, I just thought it's a good idea to show where are the career opportunities in aerospace engineering. That's related to the job opportunities. The first and foremost thing is the commercial and defense sector. You all know about what is the importance of that, especially Asian countries. Still, lot of growth is going to be happen in the commercial aircraft industry. And the other one is the defense sector. You all know that Rafael, how much we are spending. We are importing, we are purchasing many things from the abroad now. But down the line, we want to do our own. So Make in India is promoting the manufacturing sector in the defense sector. So it's a very huge opportunities are going to come. It's already got started and it will get the lot of momentum down the line. And when it comes to the places where you get the opportunities, aerospace engineering, they have the opportunities both in the public sector and private sector. I will just show some of the companies in the next slide, where you can understand what all the different companies you can get the job opportunities. Apart from that, a lot of research is happening on the space. Probably you heard about the SpaceX, ISRO, and many entrepreneurs, they started startup companies are coming up now. So huge opportunities in space exploration now. On top of all these things, you all know about the drones. Those are the game changers down the line. It could be on the commercial side or the defense side. They are going to rule. Apart from that, the other opportunities are the satellite technology. Probably you could have heard about the space-based internet technologies, Starlink, satellites. Till now, we heard about the satellites, kind of the single digit or two digit. But down the line, we are going to launch thousands of satellites, 13,000, 15,000 satellites, especially for the only internet purpose. So many opportunities are coming up in the aerospace engineering. When it comes to the job roles, there are different roles like the design engineer, computer-aided engineering analyst, shop floor engineer, production planning, quality assurance, R&D, research and development, trainees. And apart from that, the new jobs are coming, especially on the commercial flight, pilot. You all know it's not the very new, but it's there. But down the line, we are going to have the more demand for the pilots, spacecraft crew. And top of that, as VC sir mentioned, many of the jobs are coming down the line, which we never heard. So one of the job it's coming up is the drone operators. Okay, probably people who has the passion of the gaming, they can be masters in the drone operations. Here, I just to show, try to show some of the companies which are in India and abroad. This one, it shows the public companies, DRDO, HAL, NAL, ADA, ADE, BGL, ISRO, Indian Air Force, Bharat Dynamics Limited. This is the ornaments. This is the BGML, BrahMos. I just kept some of the, it's not the complete list of the companies, but I just tried to show some of the public sector companies where you can get the opportunities. And here this shows the many companies, private sector. Fortunately, earlier days those were available only in the abroad, but many of those companies, they started their operations in India. You can see many categories here. It's equipment suppliers, support systems, equipment suppliers, engines, specialists, generalists, leasing companies, airlines, MRO, many companies here I just have shown, and many of them, they have the operation in India. As I mentioned, the company name I missed to mention, Dassault Systems. So we have the collaborations with the Dassault Systems, and all our labs and these simulations, we got these things from the Dassault Systems. So it's a kind of the best softwares what we have in the Dance University. And apart from these things, these are some of the famously known companies who work on the space technologies, NASA, SpaceX, and these are some of the companies for the defense sector. And again, I'm just mentioning this is not the complete list, but it just shows you what are the different companies. Okay, down the line, careers forward. We are seeing the best, bright career in industry. As I mentioned, especially in Bangalore, it is a hub for the aerospace. Many aerospace industries, they have started their operations in Bangalore. It's a huge opportunities. It's coming down. That's the bright career in industry. Or some people might be interested to continue their masters or PhD programs. Even in our university, we are going to offer the master's program, and at the same time, who get the BTech in aerospace, they can look over the other avenues also. They can go for the computers or the mechanical or electronics. As Vaibhav sir mentioned, we have the minors degree that really helps you to get it into the different disciplines. PhD programs, there are many funding projects happening in the national and international levels. And domestic, again, there are so many labs who are really interested in continuing their research. As I mentioned, aerospace is a kind of the place where all innovations and discoveries happens first. So who has the mind of doing research, it's really great area to do. And apart from that, one can take the entrepreneurship, as Vaibhav sir mentioned in his details. We have the ecosystem in the Dayanand Sagar, which promotes entrepreneurship. Those who are really interested in entrepreneurship, they can start their learnings through different courses what we offer. Okay, that's I just thought this is some of the information which can be useful for you to know about the aerospace and where the career is and what's the path. And for any other context, for any other information, please contact me in person, or otherwise you can contact the other people, admission people. Anyhow, I just have shown my email address here, chairman-ae@dsu.edu.in, and my name is Ramakumar. I'm heading the aerospace department. This is my mobile number, and this is our website. Maybe you can walk
Yes,
through
sir.
our website.
I will take it from here, sir. Thank you so much. Thank you so much. All the students who are seeing this particular screen, they must have got the email ID of Dr. Ram Kumar. Sir, thank you so much for the lovely presentation in terms of sharing the career prospects for students in aerospace engineering. Uh, could you stop the screen sharing and allow me to do the screen sharing, sir? Thank you so much.
Yes, sir.
Yeah.
Thanks a lot.
Yes, sir. Sir, Dr. Satish, it is just 2 minutes. I need something to be shown.
Sure, sure.
Okay, we would now I'd like to invite Dr. Sanjay Chitnis to give a brief details about the various specializations that are there under the computer science engineering, be it AI/ML or be it cybersecurity. Uh, I'm sure this could be a good eye opener for all the students. Over to Dr. Sanjay Chitnis.
Yeah, thank you, Shinde sir, and thank you, Ramkumar sir. So this is a very brief introduction to, there are 4 programs under computer science. So hopefully this will lead to some more questions. So we'll be very happy to take your questions after these presentations at the end. So to start with the, 1 minute. It's, I'll keep in this mode only. There is some presentation. Okay, so these are the 4 programs we have. We have BTech in Computer Science and Engineering. We have BTech in Computer Science Engineering with specialization, that is data science. Another one, cybersecurity, and artificial intelligence and machine learning. So these are the 4 things I'm going to focus today. We of course have MTech programs, PhD, as well as something called Bachelor of Vocational Studies. Before we go to the specific programs, right, I'd like to point out to a very, very recent report. This is as early as April 5th, 2021. This is from a very eminent website on jobs, that is Indeed. Indeed is the name of the job portal, where it's international level jobs are get posted there. And so this is not based on just querying somebody. This is based on the real job postings, right? So these are the top 51 in-demand technology skills. I have posted only the top 10. So first is AI, of course, right, which includes machine learning. Second is cybersecurity. If you remember the specializations I showed, we are covering precisely these 2. Okay. Apart from that, we have cloud computing, software engineering, software development, project management, UI UX design, data analytics, data science, programming, etc. So the rest of the things are covered for other branches as well. Okay, we have other programs streams as well. So what we ensure here is whether you take specialization in AI/ML or cybersecurity or data science, everybody learns a little bit about machine learning, a little bit about cybersecurity, a little bit about cloud computing. So that is ensured for all. Then when you take these specializations, you get much more advanced learning in those areas. Right? That's what we are trying to do here. Apart from these, there are many key emerging job areas, right? So of course, one is cloud-based applications. Nowadays, everything is cloud, where you see Gmail or where you see any other applications such as your e-commerce applications or Ola, Uber kind of applications. Everything actually they run on cloud, in the sense that all the computing, all the processing happens on some server, which is not physically located near us. We have something called full stack development. You might have seen a lot of advertisement regarding that. Robotic process automation, networking and IoT, augmented and virtual reality, quantum computing. So these are all emerging technology areas. So we are focusing on these as well through something what we call as electives. Okay. To support this, we have something what we call innovative curriculum, pedagogy, and assessments. Okay, so how do we do that? Very simple terms. First, students learn how things work. Okay, we should know how things work before we start building them, right? So second thing is how to make things work. And the third thing is how to make meaningful things. So meaningful things here means we are developing some interesting products or something which somebody can use, right? Somebody can pay for. So these are the basic 3 things which we make sure that students learn. Okay. So to learn that, our curriculum is divided into 3 parts. The basic part is foundation and liberal studies. So that includes all our basic sciences and all common engineering areas like basic electronics, electrical engineering, mechanical engineering, drawing. So all those aspects are covered here. Liberal studies covered aspects which lead to leadership, overall social development. Today morning, you heard from our Vice Chancellor, sir, right? There are so many skills which are required today for anybody to be successful. So this liberal studies gives you a window into that set of skills. And then the core is the one which leads to specific your profession, which is a computer science in this case. So if you are doing basic CAC, there is one set of core. I will explain that. And if you are doing any specialization like AI, ML, cybersecurity, etc., there are specific to those things. So that we call program level core. And on top of that, now we have electives, which again can be CAC level electives or program level electives. So here is an example. I'm not going to read through each and every list item here, but these are the basic CAC courses which everybody will learn. Okay, all the 4 streams, all the 4 branches will learn these subjects. So these are developed with active participation from industry partners. So each subject, suppose I take machine learning studio, we have an expert from industry who is expert in machine learning, who works with our experts, and together we have developed the syllabus for this. Apart from this, as you see, there are 4 blocks now. Your left side, we have this BTech in CSE, artificial intelligence, data sciences, cybersecurity, and basic CSE. So these are the core courses for respective branches. Okay. Again, I'm not going to go through the list, but these are the core courses they're going to learn. Right. And on top of that, they're going to learn again electives, right? So these are the specializations. Now to develop this, we have partners with industry, right? So NVIDIA is a leading hardware specialist in machine learning. We have AWS, which is in cloud computing, UiPath, robotic process automation. EC Council is a leader in cybersecurity. So we work with them to get the right curriculum, right equipment, etc. Right? So this was a very, very brief introduction to what kind of things is for this, for your future. So I'd like to end with this quotation. So computers are the future, and obviously so are you. We value you, and that's what we have designed this curriculum and everything for you. And our department of CSE is built that's trusted for future readiness, and that's what we like to offer to you. Okay, thank you. I'll be available for questions at the end. And with that, I'd like to close now. Over to Shinde, sir. Thank you, sir.
You give the screen sharing to me.
Yes.
Thank you so much, Dr. Modalities, sir. It was wonderful to understand how things are shaping up today and what kind of, because generally when the students uh, apply to us, or when they apply to various kind of universities, they are not actually very clear in terms of what kind of specializations do I take. Many students decide that they should do it later because of lack of knowledge in terms of what exactly is today happening in this specialization, what kind of job roles are available in these specializations, what am I going to do once I complete these specializations. So this is definitely an eye opener for all the students in terms of what's available today in terms of the higher education specializations under the uh, engineering domain, especially with the computer science engineering. We will now move to the next session, and I would like to one second. Let me. We are now moving to the computer science and technology, and I would like to request Professor Jasma Madam to take over the screen sharing, and please go ahead with the presentation.
Thank you so Good morning. I'm Jasma Balasangameshwara, Associate Professor and in-charge Chairman of Department of Computer Science and Technology. Computer Science and Technology offers a dual career path. We have 2 career streams. The primary career, where you have flexible learning pathways under 4 streams: Information and Communication Technology, um, Information and Communication Technology. During the from 5th to 8th semester, children learn data-driven decision-making, applications of machine learning, big data analytics, artificial intelligence. We have immersive technology, and these are the courses. Distributed ledger technology and Internet of Things tools and technologies. By going through each vertical, the children have these as the potential job opportunities, and if you have a passion to pursue higher studies, these are the opportunities. However, the children have the option of doing a mix and match, meaning to say that I can start with information and communication technology, study data driven decision making, and then do human computer interaction, and maybe go on to robotic process automation and so on. So this is primary career. You have flexible learning pathways. Then we have a career security path, where it's a personalized learning path, where the children are taught on how to stay employed in their chosen IT career regardless of the employer's economic circumstances or financial status. This pandemic has taught all of us that job is a degree certificate is permanent, but job isn't. So we need to make sure that we have an insurance in terms of our career also. We need to say have a backup plan, plan B, C, D, so on and so forth. So there's a contingency career path that involves transforming businesses with digital technologies, thinking about sustainable solutions by creatively using technology and applying classroom knowledge to an entrepreneurial project. So what are the benefits of taking the career security path? Students don't have to depend heavily on one extremely particular IT job after their graduation for their livelihood. They can support their family members in starting, managing, growing a family business as a backup plan. So this actually widens the career growth. I have already explained the flexible learning pathways as part of the primary career. It begins from 5th to 8th semester. From 1st to 4th semesters, most of the courses between computer science and engineering and computer science and technology are common. Now, coming to the career security part, from the 3rd semester onwards, there is one course under two verticals. The child has to either opt for innovation and entrepreneurship or technology entrepreneurship. If the child has a passion towards becoming an entrepreneur, meaning to say climbing the ladder quickly in the corporate world or a Fortune 500 company, then this is the ideal track that the child has to opt for. These are the courses: thought leadership, management information systems, technology strategy, and so on. Under the technology entrepreneurship track, this is ideal for those who have a family business and would like to acquire the skills required for managing, starting, or growing their family business. They start off with these courses. And winding up, like the way I've told you, computer science and technology is a dual career path. That means if you join computer science and technology, you have to take both primary career as well as pursue or get experience on your career security path. Student startups, Ritik Kaul, he's currently in his 6th semester. This is his startup. He invested 85,000, has a turnover of 14 lakhs, made a profit of 8 lakh 50,000. There's another startup, Renta Shoot. Both of these children are actually pursuing their passion. Ritik Kaul has a passion in services, and Trishal Dayanand has a passion towards photography and videography. So this is their backup career path. These are the few placements. So computer science and engineering and computer science and technology, both the branches have common placement opportunities. And to name internships, these are some of the internships that computer science and technology children have pursued. And the source for this information is available on the department website under dsu.edu.in. Thank you, sir.
Thank you so much, ma'am, for this short presentation on how students can look at computer science and technology as another career to be chosen from their side. We will now just take a seconds short break, maybe just for a minute. In the meantime, we have the next speaker getting ready.
Audio is not there, Jin sir.
Audio is not playing.
Shinde sir, audio is not there.
Yes, sir. 1 second, sir.
Same thing, no audio. Shinde sir, no audio.
Oh. Okay, there seems to be some technical glitch. However, not an issue. We'll move to
Electronic communication.
sorry, I think there's some issue with the audios, maybe in the last minute. Fine. So we now move to the Department of Electronics and Communication Engineering. And I would now like to request Dr. Vaibhav to please go ahead with the presentation to the students.
Yes, sir,
Good
over to
morning
you,
to all
sir.
of you once again. Yeah, good morning to all of you once again. I'm Dr. Vaibhav, Chairman and Professor Electronics and Communication Engineering. First of all, we'd like to see what is electronics, what is communication. Briefly, I will try to cover it in 5 minutes. Now, what is electronics? Electronics is the art of controlling the movement of electrons in order to design components and circuits that are put together to create the technology of the modern world. And what is communication? Once we create a circuit, that means once we create a mobile, it should communicate with other mobile, correct? Once we have one laptop, it should communicate with other laptop. Once we have TV, it should communicate with the satellite channel. So communication uses an electronic circuit to transmit, process, and receive the information between two or more locations. The basic components of electronics communication system includes transmitter, communication, medium, or channel. Now, what is totally electronics in communication engineering? Electronics and communication engineering involves researching, designing, developing, and testing of electronic equipments used in various systems. It also deals with conceptualize and oversee the manufacturing of communication and a broadcast system. We had the rise of AI and ML, machine learning, has introduced many opportunities for computer-aided designing, VLSI design, signal processing, IoT, and their intersections. Job opportunities. From morning, you wake up till you go to the bed. Any gadget, the students, any gadgets or device that you come across can be improvised using electronics. I'm not saying you have to invent something. You can be improvised using electronics. It may be toothbrush. So morning I feel lazy. I want my toothbrush to be automatically moved. So I can put some vibrator into it, and it will automatically start. You can dream anything. You can dream anything. Suppose there are kids who are reluctant to go for brushing the teeth. You can put some music, or you can put some LED light. Of course, it will be waterproof. And then they can be enthusiastically doing the brushing. Till you go to the bed mess. Suppose you're lying on the bed, you want to dim the lights. You can sit on your bed with the mobile, you can control the LED light. So a gadget or a device that you come across can be improvised using electronics. And this has leads to an interdisciplinary approach. This at least, so if your water heater is there, you can sit here and give the command, I want a hot water. It will start heating the water. So there is no limit to your imagination. Wherever you think something, whatever the gadgets you're coming across, you can think of fitting electronics into it. And this has led to it multidisciplinary approach. And from that, our students from mechanical and EC department had done a project on solar paint at International Advanced Research Center for powder metallurgy and new materials. If you don't find the companies in this domain, that means if you are imagining that I have to fit electronics into this, if you don't find the companies into that domain, you have to create your own company. And for that, you can become an entrepreneur, you can join a public sector, you can join a MNC, you can join any research labs. Further, you can do MTech, MBA, and MS as well. So I will share something which had happened in just few days back. A few days back, on 5th May, we had online project extravaganza, where our students had demonstrated their project, and where we had invited an internal speaker, internal evaluator. And believe me, the internal evaluators had given the comment that the project that students had done with a little bit tinkering can become a product. Projects that students had done with little bit tinkering can be converted into the product. This was the comment from the industrial expert. This was the comment that we got from the industrial expert. And how this was possible, as I mentioned earlier, because we had introducing the concept of the mini project from third semester onwards itself. Because we had introducing the concept of mini project from the third semester itself. So briefly on this extravaganza, the total 38 projects were presented in 4 parallel tracks. The evaluators were having a tough time to judge the 4 best projects. And the best projects were assisting health workers to avoid COVID-19 infection. As I told you, there is no limit to your imagination. You can fit electronics anywhere. Image analysis based particle pollution estimation. These were the 4 best projects that were selected from the 38 projects. All the 38 projects were the best, but these were the best. Medical multimeter parameter monitor. And believe my dear students, our 8th semester student had filed a patent for this. They can sell the patent to the company, or they can say to the company that if you want to hire me, take me this patent. unmanned aerial vehicle ground control software. It was a sponsor project from the DRDO. It was the sponsor project from the DRDO. So we asked our student, we say that we emphasize our student that they should create some portfolio. Whatever they had done from 3rd semester to 8th semester, if they had done some good mini project, include some certificate. If they had done some good assignment, if they had done some good reflection note, create an assignment and create a portfolio for it. Make one file. When you go for the interview, your work should be speaking for you. Your work should be speaking for you. And that is my dream for my student, that students should not go to the company, but company should come in search of our students. Company should come in the search of student. Lot more patent we will be guiding our student, find more and more patent, so that students should come and in search of our student. Oh, this is the project. I want this medical multimeter parameter, medical multi-parameter monitor. So student can join that company. At the end, we create intelligence in silicon. I'm Dr. Vaibhav. My number is 7259-108645. You can contact me anytime. I will request you take the informed decision. Informed decision is always the right decision. For any type of your queries, I will be available for you 24/7. And my dear students, keep this in the back of mind that you can improvise any gadget using electronics, and we will help you once you come to our department, electronics and communication. Thank you very much.
Thank you so much, sir. It was a good short presentation for all the students to understand what are the careers and the opportunities that they have under the electronics and communication engineering. Could you stop the screen sharing and give me the permission
Sure,
for screen sharing?
I had stopped, sir.
Sure, sir. Thank you so much. Okay, so we would now like to move on to the next presentation for the day. And I would like to invite the chairman from the Mechanical Engineering Department, Professor Dr. Rajgopalan Iyer, to share his views on the career opportunities to the students for on the mechanical engineering side. I will quickly have his presentation also uploaded. Just give me a second.
Thank you, sir. Thank you, Dr. Shinde, sir. Am I audible?
Yes, sir. Just a second. I'll have your. Yes, sir. All yours. Please go ahead.
Yes. Thank you, sir. Now, very good morning to all the participants, the prospective students. So mechanical engineering, as you know, used to be the evergreen branch of engineering. Anything and everything which moves, which rotates is mechanical. Be it an automobile, be it a ship or an aircraft, the unmanned aerial vehicle, anything and everything. So the power what you get is be through steam turbines or gas turbines or solar panels, wind. So everything is about mechanical. But what has happened in mechanical engineering is it has got completely redefined. A lot of inputs were given by our Honorable Vice Chancellor, sir. The technologies have revolutionized the engineering disciplines. More so, I would say mechanical engineering. It has got completely redefined. So because machines are becoming intelligent, with sensors embedded into it, and there's a lot of controls. So if you look at mechanical, there used to be pure mechanical device sometime back, but now it's completely mechanical embedded with electronics circuits and controlled by software. Okay, so it will remain mechanical. The heart remains mechanical, but a lot of controls and automation has been given. Okay, now coming to the job opportunities in mechanical, we have the traditional domains like automobile, aerospace. We also have a aerospace department. So mechanical, again, it will be generic on mechanical. You have the traditional domains like automobile, aerospace, manufacturing, heavy machinery, energy sector, traditional, renewable, mining, petroleum, heating, ventilating, air conditioning, the fluid and turbo machinery, construction, building sciences, and everything. Okay, these are the traditional domains. This will remain. Again, this will get redefined with a lot of electronics and programming coming into these products, their making of products, maintenance of that, and making improvements on that. The emerging domains are even more interesting. Robotics has made inroads. Anything and everything is becoming automated. So you have a robot, you can get assistance nowadays from robots. So hazardous environment robots have been used earlier, and now the entire mechanical domain is getting automated. India has gone for a semi-skilled automation. That means we have huge manpower. So consciously we have gone for semi-automation. But because of the pandemic and other things, as we know, mostly we are moving into completely automation. So the current designs will get changed. New products will emerge. They have to be maintained. They have to be manufactured. Okay, then they have to be reinvented. So these are the new things. Additive manufacturing, as you know, including a building, everything can be 3D printed. A building can be made in about a week's time. But the heart there is 3D printing. The materials. What are the materials I'm going to use? Tissues, human tissues can be 3D printed, including the prototypes, gas turbine blades, okay, metallic, plastic, any other material. Lot of research is going on 3D printing. It's going to emerge as a major area, as our Honorable Vice Chancellor was mentioning. Earlier, we have the IC engines vehicles, but now the emerging domains are completely going to be electric and hybrid vehicles. But vehicle is a mechanical domain. So be it electric, driven by electric, but the vehicle has to be comfortable. It has to be luxurious. The noise, vibration, and harshness has to be minimum. It has to endure for a long time. You should not feel any vibration. So it will remain again mechanical. But a lot of, as I said, a lot of electronics and the microcontrollers are going to control the vehicles. The new vehicles such as hyperloops, the flying cars, the drone technologies gain importance. So everywhere you require mechanical. Okay. So next slide, please. Okay. So those are the opportunities, career opportunities. Okay. The higher education, other than the job opportunities, the career opportunities in higher education, you have the traditional mechanical engineering, design, masters in design you can do, machine design you can do. You can get a master's in advanced materials. As I told, this almost 80 to 90% of the patents filed in today's world, or even earlier, will be on materials. It is the materials which is going to redefine this world, and technology will keep pace with that. So always there is a tussle between materials and technology. So sometimes technology moves front, material is not available, and many times materials move ahead and technology is trying to do a catch up. So mechanical is all about advanced materials. Additive manufacturing, I told you about 3D printing, metal printing have come. Any materials can be 3D printed now. Product design, it's everything is virtual. You use all the CAD software and you are going to make new products. You can test the product on the computer itself and then release to the market. So virtually everything will be done on computer. So gone are the days, old days, when we had a drafting board and things like that. Now everything is, you're thinking in 3D, you're making it, and then actually releasing drawings also from the computer. As I said, robotics, you can do a master's in robotics and automation, computational mechanics, and the other things, of course, automobile, vehicle engineering, vehicle dynamics and controls, hybrid and electric vehicles, both in design as well as in engineering, and of course, computational fluid dynamics, energy engineering, renewable energy, aerospace, aeronautics, and many interdisciplinary also is possible. Sir, next slide, please. And not to be let down, what are the interdisciplinary? So you can get into biomedical engineering. As the pandemic has proved, lots of new devices have come. So there are a lot of mechanical things, but you need to understand the biological aspects, how it can be embedded to the human being. So that engineering, that human engineering comes into picture now. Environmental engineering has been a traditional one. Sir was telling, next 20 years we don't know what is going to happen. There's a lot, many environmental hazards might occur. So everywhere, so environmental engineering becomes important, but the products are mechanical. So how the environmental aspects are built into the mechanical design is something very important. So you can do a master's in environmental. Of course, as I said, everything mechanical is defined with electronics. So mechatronics, many interdisciplinary are there. I have not listed them. And of course, our Vice Chancellor sir was telling, everything is about data analytics. You have large, huge data, mine them, take decisions based on that. So it's, for example, a gas turbine plant. So GE monitors all their gas turbines sitting in one control room everywhere in the world, just at their fingertips. How is it possible? A lot of data is available. They monitor the health of the machines. They take proactive decisions. Okay. So everything is done in one single room. So that is possible now. Artificial intelligence and machine learning. So we prepare them. So these are the things which has almost made inroads into every engineering. AI and ML is the most important. IoT, Internet of Things. As I said, all mechanical devices will get embedded with sensors and there'll be control systems. So we are going to make products better, more luxurious, more affordable. You can control sitting at home. A mother can look at the house, how child is behaving, how everything, whether it is safer. So everything about this is possible because of IoT and these technologies. And of course, mechanical has been very popular in entrepreneurship opportunities. I have listed few. Product design means anything and everything you can do product design using all state-of-the-art software. CAD, CAM, CAE software. Research and innovation is possible using this. Okay, so entrepreneurship, you can do a research entrepreneurship. Innovation, you can do HVAC, heating, ventilation, air conditioning. Now you have seen pandemic, air conditioning is required, oxygen cylinders are required, entire pipeline has to be automated, controlled. So it has to become interdisciplinary. Maintenance, of course, everything has to be maintained. The oxygen system breaks down, we have seen what happens. Next slide, please. Yeah, what are the typical job roles? You have already understood this. So somebody has to do a research. I will start with research. Somebody will do a research on the new products, and then those products will be designed. So there will be a design engineer, there's a CAD engineer. This CAD and design engineer are overlapping. So if you look at the software in DSU, we have virtually all software available in mechanical and aerospace department. So we have the Fusion 360. Every student can have a copy of that. We teach them design thinking and innovation through that. We teach them drawing, then the 3D modeling. Okay. So all these things are also taught. CAE is computer aided engineering. Instead of actually testing, you can do a crash test of a mobile. You do a crash test of a mobile or crash of a car. Actually, you did not fail the component. So you can do everything using ANSYS LS China. You can do a crash analysis using CAE. So shop floor engineers is another role where you're going to monitor the things. Of course, it will be automated. Production supervisors, engineers, slightly it will get redefined. Planning is very important. Planning engineers, methods engineer. Constantly you are reinventing, redevising the process. The processes are going to be redefined. So methods engineers. Quality assurance, it has to be maintained. Maintenance engineer, safety engineer, research and development training, marketing training, management training. These are some of the roles. This is at the beginning of your career. Of course, you will grow and you will become a manager. Next slide, please. Yeah. So how do we prepare our mechanical engineers with this? Already, I don't want to repeat. Vaibhav sir has mentioned all these things, and our Vice Chancellor also said the curriculum design has enabled us. It's a private university. We have the open electives where mechanical engineers can take other department electives. Then we have the minors. The mechanical engineers can take a minor in CS or electronics, or they can do a specialization in aerospace, okay, or in mechanical subdomains like 3D printing. So what skills we offer you? We train you with all CAD, CAM, CAE software. We train you on that. We teach you the conceptual designs, coming out with product design, automation technologies. We have innovation labs. Autodesk, we have a big innovation lab. Almost every student will visit that. Automation technologies with Bosch, They are the pioneers in vehicle technologies. So we have automation technologies. Vaibhav was also mentioning, Dr. Vaibhav was mentioning about ETAS lab. So it's an interdisciplinary with mechanical and electronics. In first semester, the students will get to learn, in addition to C, Python programming. We have made these changes in the curriculum. AI and ML consciously will start from the fourth semester onwards. Mechanical people will be introduced to these technologies, data analytics, IoT. So these are some of the skill set we are going to equip the mechanical people with. So about placements, I think that will be the last slide. About placement opportunities, I have not listed the companies. As you know, all public sectors require mechanical. The majority of the jobs required still in public sectors is mechanical, but it will get redefined, as I told you, be it BHL, DRDO Labs, BEL, VSSC, ISRO. Okay, so you'll be a proud public sector employee because they are offering a lot of challenges now. Private sectors, I have not listed, it will go to many pages. Automobile itself, if you look at, a lot of engineering services is there in automobile and aerospace. CAD, CAM, CAE, all these things will be done with the software what we are going to train. So engineering services is a huge opportunity. So most of you will be doing product oriented or client oriented projects. And of course, you have the automobile, aerospace, and the other sectors. Okay, so the interdisciplinary sectors, as I told you. I think that will conclude that. And as I told, we have a very good innovation lab. We keep encouraging students to innovate using the product design labs. Placements are pretty good. Almost 60 to 70% of mechanical people are getting placed. Even, for example, Infosys hires mechanical people. They train you for 1 year, and then they will put you, if you have a good mechanical background, they will put you in engineering services. Arvind Srinivas will talk about TCS opportunities for mechanical. Almost 1 out of 4 people will be in mechanical domain. So even TCS, Infosys are slowly becoming product oriented. They are doing a lot of interdisciplinary projects. Okay, so we train you well for a bright career. We have completely redefined mechanical engineering. So take your call. So take your decision based on what inputs you have given. I wish you a bright career. Thank you, sir.
So thank you so much for the information on to the students in terms of careers in mechanical engineering and the way forward. And yeah, we do see some queries coming in from the students, but we will take up the queries after we finish the session with the industries person. We will now like to move on and like to have the perspective of the industry in terms of how the today's programs, the today's uh, specializations are being groomed or are being looked upon by the industry in terms of the placement opportunity for the students. I would now like to invite Dr. Professor Arvind Srinivas, who's from IIT Chennai, IIT Madras, of course, and has spent uh, huge 35 years of experience at TCS. He's one gentleman who must have seen the beginning of the computer era, the Y2K issue, as well as how the TCS has moved from where it was to $1 billion company today. The experience sharing will be very good in for all the students today who are attending this session. I would now like to invite Professor Arvind Srinivas to take over.
Thank you, Shinde. I'll be sharing my screen. Hope I'm audible.
Yes, sir.
Oh, thank you. Yeah, this is primarily a short talk. I don't want to take more than 5 minutes because all the other distinguished speakers have taken a lot of time. I just thought I'll try to cover only 3 aspects from an industry perspective.
The screen sharing is yet to come.
Oh, okay. Yeah, is it coming now?
Sir, 1 second. It is just. Sir, you can go to the slideshow.
Yeah. Just give me 1 minute, please.
It is down there only.
Yeah, that black stick is blocking my. Yeah.
Yes, sir.
Yeah, so I just thought I'll try to talk only on very 3 simple messages which I want to give you. One is what exactly is the industry looking when what do I look for if I were to hire anybody from an engineering background, and typically what is it that the emerging industry of all these engineering disciplines are wanting. That's the second message. In other words, my other colleagues spoke about interdisciplinary, or what I call as hyphenated engineering courses are all about. And finally, as a fresher, what is it that you need to do? I just want to only convey 3 messages to you, nothing beyond that. The first message which I want to convey to you is on the screen which you see right now. This is primarily how the industry evolution is happening right now. On the top, this basically interplay between the 3 gears which you see on the top: the industry conduct, or the core sectors like the crude oil, refineries, steel, cement, how they operate. And then subsequently the core sectors, they operate on the lower one, which you call the demand ramp up by the realistic adoption by companies which are predominantly in the secondary sectors such as construction, utility, services such as IT, retail industry, banking, and all that, how this happens. And in the middle of the screen, you see the gray colored gear, which is actually called the supply, which is actually going around in terms of these engineering colleges and students, which are providing the capacity with the right quality for them. So I just thought that you need to understand this whole concept of the interplay between the industry, the demand, and the actual supply which is happening. So what is it that we as an industry look for? We are looking at broadly 3 areas: as synergy between the knowledge, the skills, and the attitude. Just to give you very quickly what exactly is knowledge. Knowledge is very simple, as you can see on the screen in the pink color. It's something which what I know, and this is something which is typically taught in higher education institutes, including engineering, but it's also taught in non-engineering schools as well. It could be your knowledge about art, history, mathematics, physics, chemistry, or probably like what you heard, mechanical engineering, aerospace engineering, and things like that, and the basic principles behind what exactly it's all about. The other one which you see on the left hand side is called the skill. Skill is the capability to do something, and this is going to tell you how you do certain things. For example, you could be very good at singing, or you could be very good in using the mobile app, especially because you're all digital natives, unlike most of us who are all digital migrants. And skill refers to the knowledge and applying it in the right context of what one needs to do. And this is also something which you learn typically in the higher education schools. And then coming to the bottom right hand circle on the Venn diagram over here, you see the attitude. Attitude is something which is a behavioral aspect. The way you think about certain things, the feelings which you have about, it's partly something between your belief and mood. And this is something which is groomed by you in your formative years right now until you have, it could probably be formed by a circle of friends, by your family, the friends, and all of them. And this is something which tells you in terms of why you need to do that. So just to explain a little bit more about knowledge, what is it that you learn typically in a school of engineering, especially in higher education? You learn about the basics of theories, the information, the facts, the description, and the sciences. And then the skills is primarily, people sometimes have the natural skill of ability to supervise, the people skills, organization skills, or drawing skills, public speaking skills, and all that. And attitude is something which is, as I said earlier, the behavioral aspect. It's things like integrity, self-motivation, surprise, commitment, and all. So we look at the intersection of all these 3 and then arrive at what is the ability for a student who is going to join my industry or my company, and how do I go about doing it. This is something which I thought was a very important aspect, because most of the students, what we have seen is generally having limited knowledge, very good skills, or probably a right balance of knowledge, skills, and attitude is sometimes not available. Knowledge and skills may be very good, but if there's an imbalance in attitude, then I would rather have a person who's willing to do what I want rather than with a different attitude. So going on to the next one, this is about the interdisciplinary approach we talked about. You can see primarily it's enlightening things in terms of the 5 disciplines which you see over here. We did hear different speakers from the aerospace, mechanical, EC, the CST, and the CSE departments. And the people who wish to get into these interdisciplines start out by studying subjects which are considered fundamental to traditional engineering, such as mathematics, chemistry, and mechanics. This is supplemented with courses in liberal arts, like the way Dr. Sanjay Chittis talked about. And beyond this, it's up to the interdisciplinary student to fill this curriculum. You have the choice of, especially the way you heard about major and minor options. So this means that two students, in the starting of the beginning, they can follow 2 different educational paths on what their engineering interests are. And that's the beauty about interdisciplinary approach. And innovation today requires companies to monitor and integrate a multitude of dimensions: technical, financial, social, legal, and organizational, as you can see here. And just giving a small example, in Tata Motors, where we used to start with our original Indica, which was considered as probably a truck, and then coming on to the Ultros over here. You can see a car manufacturer earlier. He was driven by pure play mechanical engineers. But then, as Dr. Rajagopal mentioned, it's an emerging discipline with several disciplinary activities merging across. Now look at the car design. It's done by design engineers with a separate capability of what we call design engineering. They look at the usability of the car, the dashboard, the glove box, the mobile charger, the GPS, the map, the LCD screen for the electronic and communication engineers, and then leg space for the passengers in the rear. The electrical engineer comes in for the mobile charger. The ECE guys come into the network for GPS, map for the software guys. The aesthetics, the dashboard, exterior, all these things are done by aerodynamic bodies, which partly comes from the aerospace. Now I can't keep hunting around different people exclusively for a small portion of my work. Therefore, I want to have an interdisciplinary approach. It means, as an engineer, I may focus on one as an anchor, but then I need to have the capability to do several things. And I think, as our Honorable Vice Chancellor mentioned, many of these current day digital trends have become hygiene factors in almost every engineering discipline. Gone are the days when Excel was being taught, or Word was being taught, or Android, or mobile app, or WhatsApp, or Telegram was being taught. It's all become hygiene factors. And now collaboration, networking is part of every digital native. So given this interdisciplinary approach, I just thought I should also focus on the kind of roles which are typically available. I've just illustrated a set of 10 roles over here, and in 10 different areas. I mean, in fact, I alluded partly to what the Vice Chancellor mentioned earlier in different technologies, and I also picked up whatever the other colleagues of mine in different departments spoke about cloud computing, with the black colored font indicating the illustrative set of roles, like cloud infrastructure, software architect, or RPA, robotic process automation, which could be in the field of mechanical or aeronautics, or data analytics, which is pure mathematics, statistics, and machine learning, which is ML, or information security, which I believe is going to be the key thing, incident analysis, forensics, and especially when the world is going to move digital. And as we heard earlier, that the pandemic is probably going to have on and off intermittent classrooms with remote learning. Information security is going to be very key for all of the full stack development, as Dr. Chittis mentioned, or the mobile apps, or AI, or the IoT, Internet of Things. Like you must have seen the Havells advertisement of the fan, where the brother and sister talk about how to switch on the fan without even going to the wall, and then using the mobile app, or probably using Alexa. These are things which come out as part of the IoT, or the DevOps, which is primarily releasing different products across. But again, there are certain people who may be good in the engineering, but probably are very good outgoing social activists and all. And which is where you have the career in project management, where you start off as a module leader because they're very good in coordinating people. You have the natural instinct of people skills. You become a project leader, program manager, or if you're pure quality person, then you can become a certified quality analyst and things like that. So finally, to talk about what is it that typically we look at from an entry level perspective, you need to have a process mindset. Process mindset is something which you must be able to do things repeatedly. And every time you repeat yourself to do, you must be able to do better than the previous time. Your ability to relate to real world problems in terms of not identifying problems alone, but also being able to have abstract problems identified, of being able to correlate things. And as we spoke earlier, a multidisciplinary review, which is what nowadays the emerging engineers are looking for. On the attitude, we look at the communication skills and also team skills and all. We look at good reading habits, current what do you call career development, I mean, the current affairs and things like that. And obviously, people who have a motivation and ambition to do career. These are things which we look from an industry perspective. And again, I want to reiterate the aspect of knowledge, skills, and attitude. So with this, I just thought I'll conclude and hand over back to the panelists, and then we will have a small Q&A session.
It's already late. Where's Arjun?
He's looking for universities, right? Maybe he's held up there.
You look so tense. By the way, did you get to choose the university?
No, I'm unable to find a university that meets my requirements.
Whoa. Meet your requirements? What exactly are you looking for?
I'm looking for a place that gives me an opportunity to grow, to excel, to invent, and to innovate. I want to be a part of an institution that paves my way to discover myself and to witness the world moving forward in technology. I want to go to a place that sets a futuristic pattern of education filled with ideas and radical performances. Basically, I want to live my dream.
Dayanand Sagar University. Live the dream.
Sir, video is not playing actually. In the last video, we were able to hear only audio.
Yes, that is correct. During the initial part, we heard the music, but not the video. But now both of them are not.
Shinde?
Shinde sir, you're not audible. Shinde sir, you're not audible.
Yeah, Shinde sir, it's video and audio both are not working.
Shinde sir, you are not audible, sir.
Can you hear me now?
Yeah.
Yes, sir.
Yeah, thank you so much. I would now request the Honorable Vice Chancellor, sir, to give the concluding remarks and the guidance to the student, after which we shall also intimate them in terms of the process at Dayanand Sagar University. Over to Honorable Vice Chancellor, sir.
Thank you, Ms. Shinde. I'm extremely happy that the good number of students have attended this session, got some idea with regard to careers in engineering. And 3 or 4 points I would each one of them to understand. Number one, the going forward, please remember one important thing, because students and the parents keep asking me this question, whether the branch of engineering is important or the college is important. In my understanding, both are not important. You are important. It means a student is going to be very important than the branch of the university. That's number one you need to remember. Second, please follow your passion, whatever you like. For example, you're good at mechanical engineering. Please go ahead and do mechanical engineering, because going forward, mechanical engineering will have all the components required for the future. In the sense, it's going to have little bit of electronics, little bit of computer science, little bit of mechanical engineering. That's how the things are going to be in the future. Therefore, branch of engineering, any branch of engineering will have computer science and electronic components going forward. Therefore, there's no need to worry about taking a particular branch of engineering all the time. This is the second point that you need to remember. The third point that you need to remember is there's a lot of paradigm shifts that are happening. The paradigm shift that's happening is we need to move towards context-driven curriculum. Context-driven curriculum in the sense we need to work on or design the curriculum to solve the problems of today. You cannot work on the problems of the yesterday. You cannot study something which is outdated. Therefore, the curriculum has to be updated all the time. Therefore, all the universities trying it, particularly Dayanand Sagar University, is doing its best to provide that updated curriculum all the time. The second, the kind of assessment that are done in Dayanand Sagar University are far different from all the others because we are aware future requires the three important skills which Arun was mentioned just now: ASK, attitude, skill, and knowledge. And Dayanand Sagar University will have the assessment components to give you impart all the three skills: the knowledge component, the all the three components, the knowledge component, the skill component, and the attitude component. The last thing that you also need to remember is going forward, if you are good at only one aspect, that's not enough. You need to be good at the multidisciplinary aspect. Second, you also need to see the connection from one field of study to other field of study. In the sense, if you are studying biology, when you are studying biology, you see whether these biological concepts have a relation to computer science, have a relation to electronics, have a relation to mechanical engineering. That is what is required. Suppose you study something about history. Can you see history to some other branch system of field of study? That is what is required. Anybody who can see connections across disciplines are the ones who are going to succeed. Please understand, going forward, everything will be either interdisciplinary, interdisciplinary, multidisciplinary, or transdisciplinary. It means within the domain, just outside the domain, outside the field of study. And that's how the things are going to go in the future. And going forward, jobs are available. We don't have to worry about the job scenario at all. There are plenty of jobs that are going to be available. All that is required is a person who has the skills, who has the ability, who has the master the skill of seeing connections across multiple things are the ones who are going to succeed. Therefore, it requires tremendous amount of self-discipline and sacrifice. Therefore, it's necessary for each one of you to keep these points in mind and assure you Dayanand Sagar University is a well-recognized university with tremendous set of people who can see these kinds of things. They keep updating their curriculum, they teach differently, they ensure that every bit of your time in the university is useful. In other words, there'll be little bit of classroom teaching. There more of hands-on, more of laboratory work, more of skill-oriented things where you need to really work hard to build a career. Anybody who's going to graduate from Dayanand Sagar University will have a fantastic career going forward. I wish each one of you very best of luck and thank each one of you for taking your time off on a Friday to be with us to get something, some information from us. Please write to us. We'll be very happy to answer your queries. I wish each one of you best of luck. Thank you. Thank you very much.
Thank you so much, sir, for the guidance given to all the students. I would like to request all the students, in case if you have any queries, you already have the phone numbers, you already have the email IDs. You could also write us at admissions@dsu.edu.in, and we'll be happy to look into your queries and give you a 1:1 kind of a counseling session, a guidance session, which will help you to choose your careers, which will help you to choose the right kind of specializations for your careers. I take this opportunity to thank all the speakers today. It was a wonderful interaction. It was a good exploration to all the students to understand what exactly is available for them when they look at higher education, when they look at engineering as a career. We are going to have a series of such kind of programs where we could also look at each of the specializations to be taken up in details. That would be a 30 to 45 minutes kind of a session, and students, depending upon their choice, could also go forward and register. The teams will get back to you with the schedule of such kind of programs, such kind of info sessions, and you could always take the benefit of this. Sincere thank to all the students. I do understand that, because of the pandemic, examinations are not clear. In fact, students are asking about DSET. Yes, let me also brief you that with regards to the DSET examinations, which is a must for the entrance into Dayanand Sagar University, we are shortly coming up with the concept or with the activity of home-based proctor test. And by May 10th, it will be announced in our website. And all the people who have currently registered and have filled up the application form, they will be getting an intimation by email about the dates that are going to be made available for the online home-based proctor test. So this activity will be shared to our website by May 10th, as well as to all the people who are going to apply to the through the university website by paying the application fees. And the general announcement also will be made, as it is difficult for us with this current pandemic to look at the center-based online test wherein students can come to a common center. We will now be going ahead only with the home-based proctor test. So by 10th May, the intimation will be given to all of you. Yes, there are a couple of more questions which I would like to put across to all the speakers. This is a question to the panel. Will taking a specialization course be too much of narrowing down? May I request Dr. Chitni sir to look into this question. Will taking a specialization course be too much of narrowing down?
Yeah, let me answer this question. Am I audible?
Yes, sir.
Yeah. So it is not too much. Yes, definitely it is a specialization. So it is a kind of narrowing down, but definitely it is not too much. As I mentioned, we have this professional core courses about computer science. So any student who is doing specialization is basically a computer science graduate. Okay. So the basic computer science is covered. Okay. This is in addition, they get some specialization. Today, what we observe is for placements, there are many companies come and hire students for specific job roles. Like they want somebody for data science, somebody for full stack development, right? So today also students are applying and getting such jobs, but this is what they achieve based on their personal effort, right? They might have done one or two electives, they might have done a project based on that, and based on that they might have done some online courses. Based on that, they get these jobs. So today we want to facilitate that officially, right, through the curriculum itself, rather than student doing on their own. So that's the only difference. It's not narrow specialization. Students are welcome to study other domains as well. So for example, somebody special in AI ML, they don't have to restrict to only AI ML if they are also interested in cybersecurity or they're interested in cloud computing. So they can take electives in those domains as well. Okay, so they can develop the breadth based on their interest. Only thing is, this is what we are allowing them to kind of be current in the latest technology through the curriculum. That's the only difference. I hope this answers the question.
Right, sir. Thank you so much. We have another query from a student for Professor Dr. Ramkumar. This is with reference to the aerospace engineering. And the question is and the question goes like this. Sir, can we conduct research in astrophysics by choosing aerospace engineering?
Yes, sir. Yeah. Thing is, as we mentioned earlier, we don't have any limits on the type of the research what you are looking for. So if you are interested in the astrophysics, definitely yes, you can do the research in the astrophysics. We have some of the people who are working on astrophysics, especially from the physics department. We have some people. So what I'm trying to say you is some guidance if you require, we will definitely help from our side. And if it is beyond our capability, then definitely we look for some external sources and we will help. So definitely yes, whatever you want, you can do research. Astrophysics is also part of the aerospace engineering. Yes, you can do that.
Right, sir. Thank you so much. So this is what we had in terms of the queries that were being raised by the students. So with this, I would like to thank once again all the participants, all the students and their parents. Okay, there's another question that has come. I didn't understand the process of choosing electives, major and minor, and how it benefits us. Could you please elaborate?
Yeah, let me take this question.
Yes, sir.
So, for example, a student joins a BTech program in mechanical engineering. This student would study subjects of mechanical engineering, also few courses in computer science, electronics, which are required for mechanical engineering of today. That's the major degree. Minor means a student wants to know something about computer science also, because though he has joined mechanical engineering, he has developed some interest in computer science. Then he can do a minor in computer science by studying about 4 to 5 courses in computer science, those basic courses. What are those basic courses? For example, data structures, programming, operating systems. Once you have basic knowledge in computer science, you have mechanical engineering degree, you have a basic knowledge in computer science, therefore you can be taken, you can apply for a job role in software industry also. Though you are a mechanical engineering student, you can be considered for a software engineer role in a industry, in a software industry. That's the advantage that you get. For example, if you are a mechanical engineer, you have done a minor in electronics, means studying about 4 to 5 courses in electronics. Thereby, you become a full-fledged mechatronics engineer, because you are going to apply the concepts of electronics in mechanical engineering. That's what it means. Basically, you are trying to get some additional knowledge in an allied kind of a course. That's exactly what the minor is all about. Major you're going to have, and minor is to get an additional knowledge in a related domain. In additional knowledge, this also helps in some other way. For example, you are a mechanical engineer, you want to do a master's in computer science in a US university. When you go to US university to do a master's in computer science with a mechanical engineering background, then you have to study additional courses like data structures, operating systems, etc. If you have a minor, you get a waiver there. Therefore, you don't have to repeat those courses. Therefore, you can straight away get into a master's degree in computer science without any difficulty. That's how the minor degree is going to help you, either to get a job or to get some exemption or waiver of courses if you plan to do a master's in additional kind of a thing. And please remember, going forward, the basic engineering, whether it's irrespective of the branch of engineering, is the fundamental requirement. And after that, if you want to make a transition to any other branch of engineering, it's possible. For example, you are a mechanical engineer, you want to do specialize in aerospace in the master's degree, you can do that. You can do a master's in computer science, you can do that. You want to do a master's in electrical engineering, you can continue to do that. That is the advantage that you get by doing a minor and a major.
Thank you, sir. We have another question. Is it possible to do a major in computer science engineering and minor in cybersecurity?
It's not required, because cybersecurity is related to computer science. Therefore, normally you get a specialization. You get a specialization in cybersecurity, but a major in computer science. That's what it is. Because if it's the same domain, minor will not come. Minor is normally outside the domain. If you are computer science, if you do something in mechanical engineering, then it becomes a minor. If you do in the same related area, we normally call it a specialization. Specialization and minor both are similar. If you are doing some additional courses, specialize in a particular area, then it's normally called as a specialization, not a minor.
Right, sir. We have another question from a student. What is the difference between College of Engineering and Dayanand Sagar University?
Dayanand Sagar University has 3 engineering schools. 2 engineering schools under VTU. One is autonomous, another is affiliated college. Dayanand Sagar University is a state private university, has a school of engineering, is an engineering college. Therefore, there are 3 engineering schools under Dayanand Sagar management. Therefore, please remember, you can join any one of them. Dayanand Sagar College of Engineering is affiliated to VTU, it's an autonomous college. Dayanand Sagar Academy of Technology and Management is an engineering college under VTU, is an affiliated one because they follow the VTU syllabus. Dayanand Sagar School of Engineering is under Dayanand Sagar University, is a university where the degree is awarded by the university. That's the difference.
Right, sir. Thank you so much for the information. There's another good question from a student. Sir, what course can be taken by biology student in engineering who have less knowledge in computer science?
Please remember, there's no knowledge of computer science required for doing engineering. What is required is if you have basic knowledge of mathematics, that's good enough. A student of biology can also do computer science engineering. All that is required is you need to pick up that algorithm skill, pick up the basic tenets of computer science. I think it's possible to pick up whatever you are interested in. Though you are a biology student, you can also learn mechanical engineering, electronics, computer science, but you need to start liking that course. You start working hard in that course. That's what is required. Let me tell you what I have done. I did my bachelor's in electrical engineering, master's in electronics, PhD in computer science. They're related. Therefore, it's possible to make a migration from one to the other without any difficulty, without any change. All that is required is you need to pick up that related knowledge going forward. And in my understanding, bachelor's degree, the 4-year degree, is the right time for you to plan it out. At this point of time, you may not know what you're good at. Once you make a transition from first year to second year to third year to fourth year, you realize you are really good in research. You realize that you're good in programming. You start realizing you're good at hands-on, you're good at design, you're good at doing a product, you're good at laboratory work. Then you can decide what kind of career that you would like to pursue going forward. Therefore, bachelor's degree is a basic degree everyone has to possess to plan for the career. These 4 years is the right time for you to plan your career. That's how you decide what you're good at, what career you need to pursue. That's how it's going to go.
Right, sir. There's another question. This is for the mechanical engineering chairman. Sir, can we do research in mechanical engineering?
I'll take this question.
Yes, sir. It's for you.
Yes, absolutely. It depends upon which area you want to do research. Okay. So in mechanical core domain, you have many, for example, if you can do in manufacturing, but manufacturing has been redefined now. 3D printing has become a part of manufacturing. Earlier, only subtractive manufacturing was there. We used to remove the material. Then people realized what a waste. So now we are doing additive manufacturing layer by layer. And you can do research on materials, the new materials, next generation materials. And these materials are used to make a heart, artificial heart. You can make they're trying to make a lung also, artificial lung, heart. So there's a lot of research going on in the bio side. So it depends upon which area you want to do. Traditional, okay, you can do in automobile or aerospace. Automobile, again, you can get into the CFD. For example, engine combustion you can do. You can do a CFD, or you can do a you can do combustion, how to optimize the combustion process, or you can do on the structural side. Okay, so you can do a lot of structural optimization design and those areas, or you can also do on the thermal side computational fluid dynamics. Okay, so these are some areas in addition to the interdisciplinary, as I told you, could be biomedical, there is on the health sector, or it can be in mechatronics, or you can do in robotics. Robotics is one of the key areas now. So robotics and automation combined together. Okay. So, or you can also do a shift from mechanical come computer science. So that is also possible. So when you talk about specialization in mechanical domain, I have given you enough interesting parts. So does that answer your question?
Right, sir. Right. There's another question by a student. Is it possible to take computer science even if we didn't keep computer as an optional subject in 11th and 12th grade?
Yes, yes, yes,
Yeah.
yes. All that is required is physics and mathematics. After that, any other course is fine. Either chemistry or biology or biotechnology, all those things are acceptable. Computer science, anything for the matter.
There's a question from Vansidhar. Is the university approved by the State Act? Yes, it is approved by the State Act. That is why we call it as a state-private university.
No, let me answer this question. There are 5 types of institutions in this country. The first set of institutions are called as institutions of national importance, which are normally referred to as the IITs, IIMs, and others, which are approved by the Act of Parliament. Then you have the central universities approved by central government, which is numbered UGC control. Then you also have deemed to be universities. These universities are approved by central government, means the government of India. The difference is the deemed to be universities can operate their colleges anywhere in the country, jurisdiction of the entire country. The fourth type of institutions are nothing but state government universities like Vishweshwar Technological University, Bangalore University, etc. They're all confined within the state because they're approved by the legislation or the state legislation act. Then state private universities. State private universities nothing but approved by state government, but they're private in nature, but they're restricted only to Karnataka state only. They cannot go and start their operations outside the Karnataka state. In terms of the recognition, in terms of the power, etc., all are same. All are same. Everybody is going to give a degree certificate, and Dynamics University will also going to give a degree certificate. The difference is jurisdiction. Jurisdiction within the state or entire country. That's the difference.
Right, sir. There's another question. Sir, in computer science, we should be good in either Python or C++ to get placement. Is this right?
Not necessarily. Not necessarily, because it depends on the job role. But by and large, by default, anybody who's going to do a computer science must have the algorithmic knowledge. The basic foundation of computer mathematics is a must. Therefore, we teach a course on discrete mathematical structures, linear algebra, and several others. Anybody who is going to be good in mathematics, reasonably good in mathematics, are going to become good software engineers. Therefore, what is required is the logic. If you're good at logic, you will get a job. There's no doubt about that.
Another
Sanjay,
question,
if you want to add something, you can add.
Yeah, what you said, sir, is perfect. And what I'm trying to say is, see, languages are just the tools to start implementing and do hands-on activity. We give you opportunity to work in the language you mentioned, that is Python, C++, as well as Java and JavaScript, which are also very important today. Okay, so you will learn all those languages, but as sir told, they are not necessary. What is important to get the right fundamentals, know the how to solve these problems, the correct logical ability, and those kind of abilities. That's what will also help you to develop the skills. Thank you.
Right, sir. There's another question. Can we do a major in aerospace and minor in electronics?
Yes, yes, yes.
We can do that, sir.
Yeah. Anything is possible.
Yes, sir.
Right, sir.
Sir.
There's another question. Hello, sir. Is there any exchange program in DSU or any link-ups with foreign universities?
Yes, we do have. We also have a provision for a semester away program. A student of Dayanand Sagar University can do 1 semester outside the university. The credits that are earned in the other university are being transferred or being taken into Dayanand Sagar University for the degree. There's also one more question which I see here. I am doing specialized in AI and machine learning. Can I choose aerospace as a minor course? Exams are held along with the semester or held separately? The answer to this is yes. You can do AI and machine learning as a major and aerospace as a minor. That's possible. As far as exams are concerned, exams are normally being conducted for the convenience of the students. Normally, the major exams are conducted together, then the minor exams are conducted separately, so that student need not have to worry too much about the exams alone. And all that I suggest is, in Dayanand Sagar University, importance is given to learning. Importance is given for the ability to do the problems, ability to find a solution to a given problem, rather than the exams per se. Exams are just a kind of assessment, a kind of tool to check how much you have understood. Therefore, the approach that Dayanand Sagar is going to take is far different from other universities. We do not follow the kind of model that's being followed in the regular kind of universities. Here, enough things are being given. There may not be any final exam if you are given a project. For example, you're given a major project, then the major project itself is evaluated as a final exam kind of a thing. There may not be a semester end exam at all for a course. It all depends on the faculty who is going to teach a course. And sometimes you are given a open-ended problem where the faculty would guide you through the open-ended problem. Then you're going to solve it. That itself is the course that you're going to learn. Special provisions are being made here. The importance or the significance or the focus is more on learning, more on making you to solve the problems rather than the CGPA, rather than the exam, rather than the assignment, rather than the etc. That's what we normally focus more on.
There's another question. Sir, what is the difference between computer science engineering and computer science and technology?
The difference is that the basic course would remain the same. As for the computer science and technology is concerned, orientation is given towards building a product, entrepreneurship. You will be taught to design a product. For example, you get an idea. How do you take that idea from the concept to reality? How do you build a product? Therefore, a computer science and technology student can start an enterprise upon completing a BTech course, or they can opt for a job, or they can opt for a research course. Therefore, the orientation is more towards skill, more towards a hands-on kind of a thing in computer science and technology. In computer science and engineering, the orientation is more towards the concepts, more towards knowledge, more little bit of skill and little bit of attitude also being taught there. That's the basic difference. Entrepreneurship orientation is given in computer science and technology. The computer science engineering may not have that orientation.
Right, sir. In fact, the rest of the questions, we will take it up from the students in terms of 1:1. As far as the fees, the hostels, all of this information is available on our website. I would request all the students to visit the website dsu.edu.in, where hostel, transportation, all of these details are made available. There's also a helpline number available where you can call in, and 1-to-1 we can guide you about all of this. As far as DSET examinations are concerned, DSET examinations are for entrance into DSU engineering programs as well as the MBA, MTech and the B Pharma program. But once you give the entrance, and you'll also be having an interaction with the respective school deans and the professors. And once the clearance is given, we will send you the offer letter for the admissions. This is generally how the process is available, where if you write the DSET exam, there is a special fees being offered to you. You also have a choice of not taking up the DSET exam, but coming in for a direct admission. In that case, the fees are slightly higher compared to the students who are going to take the DSET examinations and come in. Students can also opt for taking admissions into DSU subject to the writing, through the CET, of course. And if the ranking is high in the CET, you can opt for taking admissions into Dayanand Sagar University. And I think, sir, most of the questions are being shared. There is one question from Rohita in terms of, can I know the list of university linked up, and also which semester and which university is the exchange program? I think, Rohita, what we will do is we will write back to you in a separate email, because this is going to be a lengthy activity. We will share with you the details in terms of what kind of university linkages and which semesters under the exchange program. And we'll also share with you a particular number, maybe a mobile number, wherein you can call up and we can share this detail on a 1:1 basis to you. So that's it, sir. I think most of the queries have been taken up. Is College of Engineering and DSU are in the same campus? No, it is not in the same campus. Our engineering activities are completely done at the Gudlugate campus. Once the pandemic is over, you can let us know, and we can also have a visit of yours done to the campus to see all the industry labs that are there, which is one of the best labs that are available today in the country. Probably this would be one of the first universities to have a variety of labs that are being made available to students. And these are labs set up by the industry. So there's a lot of research and innovation going on there.
The biggest advantage, you can do a project in one of the innovation labs that will be counted as your semester work. Semester work credits are going to be given to you. Therefore, there's a flexibility that you're going to get in Dayanand Sagar University. No other university, at least in the state of Karnataka, has so many innovation labs as DSU has, Dayanand Sagar University has.
Right, sir. So I think students, anything more, please write to us, or you can always call us. Just, if you visit the website, you'll get all the links and you can get in touch with us. So let me thank all of you once again. Special thanks to all the students who have taken out time, and to the speakers, to the industry panel, to the Honorable Vice Chancellor, sir, for your time. Thank you so much. And we enjoyed, and I hope the students also enjoyed this. We look forward to your questions through the phone number that is being shared through our website. Thank you so much. Stay safe and stay home. Thank you, sir.
Thank you.
Thank you.
Thank you. Thank you.